Hello, hello everybody. It's so good to see you here in this webinar, and I hope that we will have a good time. I'm Fanny Hajina, the chair of the Bee Health Commission, and I have the honor to be your host together with all the speakers and the moderators today from Apimondia and also collaborating bodies. First, some household issues. It's better if we all keep our microphones muted, so we save bandwidth and we can have a better sound. And people that they are participating but not panelists, they can write to us in the chat. We will monitor the chat frequently. And I would like to spend just a few minutes to welcome you all and explain why we are doing this. While we were in Chile, in Apimondia Congress in Chile, we had a roundtable about for Europe and the projects, research projects actively now running in Europe. And the discussions were very lively and very important. And then through the discussions, we realized that we do need to have better knowledge and exchange of practices and examples of how to monitor or tackle the invasive species, especially in Europe, because that was the roundtable for Europe. But of course, we are going to think about what is happening around the world. And that's how we created the idea of holding this webinar. We hope that it's going to be helpful for everybody. And the aim is to exchange knowledge, see if there are gaps and good examples also to be exchanged. And of course, to see if we could find joint activities for monitoring and say the treatment of mitigation measures. We are not going to talk about Varroa in this particular webinar. We focus only on Vespa velutina, Vespa orientalis, the small hive beetle, and Tropilaelaps, which is a new pest approaching Europe, because Varroa is already established well in Europe. Still, we need to mention that since 2022, it was found in Australia, that it was one of the few places around the world that they were Varroa free. And since that time and until September of 2023, almost 1 year and a few months, there were about 27,000 colonies destroyed, which is a massive destruction in their efforts to eradicate. However, since September, no eradication measures anymore, and Australia is now approaching other kind of ideas how to manage and still keep beekeeping as sustainable. So what I will very quickly do is I will try to share the agenda just to see what we are going to talk about today. I hope you see. Yes, now it's in full screen. Is that everything? It's okay? Yeah? I cannot hear anything.
It's fine, it's fine.
It's fine, okay, good, thank you so much. Silence is good sometimes, but not reassuring. So, in our agenda today, we have two parts separated by a break. The first part, we have two sessions that they are going to deal with the Vespa velutina and Athena tumida. Vespa velutina, hopefully, it will be moderated by Cindy Adolphe from Beekeepers. And the Athena tumida session by Giovanni Fomato, the colleague from Istituto Zooprofilattico. Then we have this break, and we will continue with the third session about the Tropilaelaps and it will be moderated by Jeff Pettis, the president of Apimondia. Then in the fourth session, we thought that it would be good if we could hear some talks about the research projects running in Europe currently and how they are going to approach these issues. This session is going to be moderated by Robert Hlebo. And at the end, we will have a general discussion and Q&A session. Still, every session we will have about 10 minutes dedicated to questions and answers. But before I finish with this, I would like to go to the beginning again from the agenda, because we invited Francois Diaz to talk to us about the invasive species in Europe, introduction to pathways and control pathways. I will stop my sharing now. And why we did that, this is our keynote speaker, is because Francois is a French national, and he had a degree of doctor in pharmacy and also obtained a master's degree in international law. And maybe these qualifications were very good in order for him to have a position as a scientific coordinator for wildlife and bees in the WAH. WAH is the World Organization for Animal Health. He is working especially in the preparedness and resilience department, and his expertise is on wildlife, as I said, biodiversity, bee health, and international transport of diagnostic specimens. So with no other further ado, please, Francois, the floor is yours, and we can start.
Thank you, Fanny, for the introduction, and good afternoon, everybody. I'm going to give a presentation on invasive alien species. So my speech will be in general at the international level, but of course it's applicable to Europe. So I'm going to start to share. Yeah, so you can see normally the presentation.
Yes, it's fine.
Thank you. So I'm going to give first to introduce what is invasive alien species, and then I will provide the WA contribution against invasive alien species. And in my first part, I will give a definition. What do we mean by invasive alien species? The different type of invasive alien species for bees, the different introduction pathway of the invasive alien species, and then I will conclude this part by the management of invasive alien species. So what do we mean by invasive alien species? A definition is given by the Convention for the Biodiversity, and it's according to this definition, invasive alien species are animals, plants, or other organisms that are introduced by humans, either intentionally or accidentally, into places outside of their natural range, negatively impacting a native biodiversity, ecosystem services, or human economy and well-being. And you can see that we have so different type of invasive alien species. We can have, of course, the mammals, the reptiles, the birds, the fish, amphibians, the terrestrial and invertebrates. We have also plants, but we have also microorganisms. So regarding the bees, you can see on this slide the different type of honeybees living worldwide. We have, as you can see, Apis mellifera is the main species of honeybees, but we have also other Apis, and so we have Apis andreniformis, Apis cerana, Apis dorsata, Apis florea, Apis kochpevikovi, and Apis nigroscincta. But we have also other type of bees that are not included in this slide because we have stingless bees, and we have also many other bees that produce honey, but it's not on this slide. And also on this slide, we don't have, for example, Apis mellifera is seen as something unique, and but we have different subspecies of Apis mellifera, and including some that can be considered as invasive alien species. And I will give an example in this presentation. So what are the different types of invasive alien species for honeybees? But so as I say, we can have bees. Bees can be invasive alien species for other bees, and a good example is Apis mellifera capensis that can be very invasive, and so the introduction of these species of bees need to be carefully survey and to limit and to avoid, forbid the importation of these species of bees, because as I said, they can be very invasive. We have also predators, like for example, Vespa velutina. We can have parasites of honeycombs, and a good example, it's a small hive beetle. We have also parasites of honeybees itself, and Tropilaelaps like Varroa are a good example. And we can have also pathogens. And here I gave the example of Nosema serenae, but we have many other pathogens that can be considered as invasive alien species. We have different type of introduction pathway for the invasive alien species. And regarding honeybees, we have two main pathways. We have the international trade of bees and bee products. And so this is the main pathway for most of the invasive alien species for honeybees. But we have also the international trade of furniture, plants, and many other things. And this it's an example of a pathway for the predators and parasite of honeycombs. And so, for example, Vespa velutina is also a good example, because it was introduced in Europe through the international trade. I think it was of plants, because it came with the ground that was with plants, and so this is a tricky pathway. But as we can see, the most pathway of introduction are through the trade. And so it's what I say, we have different pathway, but at the end, it's a similar pathway, because it's through the trade, the international trade. And you can see that on this slide, because so the economic are the most important pathway for the introduction of invasive alien species. And regarding the management of invasive alien species, it's very important to prevent the introduction and then the establishment of invasive alien species, because after, and here you can see it on this slide, it's very difficult to limit the spread and to eradicate these species when it's established. And so it's why the most attention and the most efforts has to be done on to avoid, to prevent the introduction and the establishment of invasive alien species. So now I'm going to present you what the World Organization for Animal Health does regarding contribution against invasive alien species. And I will present the different tools that we have to fight the invasive alien species. We have the WUA standard, we have the World Animal Health Information System. We have some WA publication. And I will conclude this part in my presentation by the gaps. What are the gaps, the things that we don't do and need, that where there is a need of action and tools. So first, the WA standard, the standard of the World Organization for Animal Health are laid down in 4 publications. So the 2 codes, the Terrestrial Animal Health Code, the Aquatic Animal Health Code, and the 2 manuals, Manual of Diagnostic Tests and Vaccine for Terrestrial Animals, and the Manual of Diagnostic Tests for Aquatic Animals. All these publications are available on the WA website, and they are available free. So the aim of the Terrestrial Animal Health Code is to assure the sanitary safety of international trade in terrestrial animals and their products, while avoiding unjustified sanitary barriers. And so this is very important because it is going to provide tools to avoid, to prevent the introduction of invasive alien species. We have, so as a relevant chapter for this issue, we have general chapters, and we have in particular some on the animal disease surveillance and notification, the chapter 1.1 on notification of disease and provision of epidemiological information. We have also the chapter 1.4 on animal health surveillance. Regarding bees in particular, we have the chapter 4.14 on official health control of bee disease. It provides a kind of a framework on how to organize the health control at the national level of bee disease. We have also the chapter 5.10 that provide model veterinary certificates for the international trade. And we have the chapter 9.1 to 9.6 covering the 6 BDCs, including in the list of the World Organization for Animal Health. And I will come back. I will come back on these, on the 6 different BDCs included in this list in my next slides. And so this chapter on the BDCs provide the safe commodities, so the commodities for which you have no risk of introduction of pathogens or invasive alien species. You have also a part on the determination of the disease status in a country, zone, or compartment, and on the recommendation that you can apply for the importation of live bees and product of bees. So all, as I said, all this information is available on the WA website, and so here you can see where they are on the WA website, and you have also you can scan the QR code to access directly on this. We have also, as a companion volume of the code, we have the terrestrial manual. And these provide the internationally agreed diagnostic laboratory methods and the requirements for the production and control of vaccine and other biological products. So you are going to say that for bees, there is no vaccine. Alors, for the moment, yes, but as you are maybe aware, a vaccine has been produced and has been is on the course to be in the market regarding American football. So this is a good news. Again, all this information is available on the WA website, and so here you have where it is on the website, and you have the QR code. We have also the World Animal Health Information System. So through this system, we have a notification of the epidemiological situation from all the member countries of the World Organization for Animal Health. and for a limited number of diseases listed by WA and regularly updated, as well also as for emerging diseases with significant morbidity or mortality or zoonotic potential. And currently, as I said, 6 BDCs are present on this list. It's a carapacidosis of honeybees, American full-brood of honeybees, European full-brood of honeybees, small hive beetle infestation, Tropilaelaps infestation, and Varroa. So this system is of interest for all the countries, and because it's first, it's a system that is useful at the different level, at the national, regional, and worldwide level. For what? For adapting animal disease prevention and control policy, for adjusting animal health priorities, for implementing import risk analysis in the case of trade and movement of animals or product of animal origin, and so for also preparation and anticipation. So this World Animal Health Information System is useful for, of course, the prevention of the introduction of invasive alien species, but also to prevent the establishment, because if we have an early detection, we can avoid and prevent the establishment of an invasive alien species. You have also all these information on the website, and you can see here where they are. We have also publication, publication relevant for invasive alien species. We have a scientific and technical review, which is now a little bit outdated because it was released in 2010, but it's two parts that provide general, so first part on general aspect and biodiversity, and the part 2 on the concrete example. It's still an interesting tool and useful publication. And we have also, again, a little bit dated now, but we develop guidelines for accessing the risk of non-native animals becoming invasive, and these are available on the website. And so now, and I will conclude my presentation on this, it's the gaps. We saw through these presentations that the WA standard and WAIS, so the World Animal Information System, provide tools to support countries for the prevention of the introduction through the international trade of bees and bee products, and for fighting the establishment of invasive alien species. But we have gaps, and these gaps are mainly regarding the international trade of plants, furnitures, and all the international trade in general, where you can have the introduction of an invasive alien species, but for which is very difficult to do something to it recommends some surveillance, but very strong surveillance, and sometimes it's difficult to avoid the introduction of invasive alien species through this international trade. We have also some gaps in the management of invasive alien species once they are established. And so these include also the eradication. And as we can see, sometimes when it's the invasive alien species start to be established, it's difficult to limit. And we saw that with Varroa. We can see it also in general with different invasive alien species. It's the prevention of the introduction and the prevention of the establishment are very key to manage the issue. And after, it's very difficult. And for this, I think we need some support, some guidelines, and some work on that. And so I thank you for your attention. and I wish a productive and interesting webinar. Thank you.
Thank you, Francois. Thank you also for keeping the time. We are very good on time, and I hope that the rest of the speakers, they can also do the same. Could you stop sharing, please? Thank you so much. So we did not foreseen any Q&A on this talk before we start, because that was an introductory presentation. Still, there are a few questions on Q&A session, and maybe then we can see them at the end. Okay, we can continue now. It's better if we continue now, yes, I think, and then we will see them at the end. So Francois, you can also see them, and if there is something that you can answer directly, okay, otherwise we can answer them online so everybody can hear. With this, we go to the first session, and I think that Cindy managed to be with us. Is that correct, Cindy?
Yes, I managed.
Okay, please
Thanks,
take it over. Thanks a lot.
Yeah, so hi everyone. So I have the honor to replace my colleague and friend Noah Simon, a last-minute replacement, but I hope I will manage to do it, as it's my first time to do such exercise. So we begin this webinar with the invasive species that is now spreading all around Europe and threatening the honeybees colony, so Vespa velutina or the yellow leg hornet. This year is the 20 years anniversary of Vespa velutina in France, and its presence was first recorded in Lot-et-Garonne. I invite you to visit this place. It's a nice area in south of France. And in order to be precise, as my ex-colleague Quentin is the next speaker, the hornet lineage belongs to the variety Nigritorax. So our agenda is dense, so let's go directly to the point. We have 5 sessions about Vespidae across Europe, Vespa velutina, but also Vespa orientalis, as it's also a growing problem. And at the end, we will have a question and answer session. As timekeeper, I will ask the speaker to respect the time, or we won't have the possibility to have some exchange at the end. So now, Quentin is a researcher at the National History Museum of Paris, and let's say that it's one of the most skilled persons on Vespa velutina, and he will present to us what has been done in France regarding data and the monitoring impact of Vespa velutina in France. So Quentin, the floor is yours, and you have 7 minutes.
Okay, it's fine, it works.
Yeah, it works. You can.
Okay, so I will go quick because it's a short presentation. The first thing is we monitor the species. I made these maps of all the monitoring in Europe. French data are available on INPN OpenOps. They are freely available, and on the GBIF. And as you see, the hornet was detected in 2005, and is spread at a rate of 80 kilometers a year. And you know the distribution today, and it was detected at around the same time in South Korea, and in 2015 in Japan, and last year in USA. So you don't see this country in the map, but it continued to spread in the world. I put the link. I don't know if you see my mouse. I think I hope. I put a link here of a dedicated website we maintained about the species, the English website, and soon I hope I will have time to explain better how to take the data, the French data and international data, because it's not clear today, and it's important to have validated data, and there's many things to be careful when you use it. All these data help us to understand the nesting preference of the species. We know now that the species is preferred urbanized area than natural areas. And we can do also niche modeling of the species with mean climate data. It goes from its suitable areas. It goes from purple to yellow. More it's yellow, more it's suitable for the hornets. And it was done with mean climatic data. So it's the hornet as the wasp, social wasps, they can oscillate greatly year from another. And so it oscillates around this mean. And as you know, as you probably know, the two last year were very suitable for this hornet, and they spread more in the north. And to determine the impact of the species, the impact on insects, we study the prey spectrum and the quantity, the amount of prey a colony will need. To do that, we dissected nests and count everything inside. And we can say that a colony of hornets, of Vespa velutina, can eat around 100,000 insects, which is around 11 kilograms of insects each year. So the colony is annual colonies, and in the season they can eat 11 kilograms of insects. But it's not all insects, and we can see that it's an opportunistic species. It eats everything it can find, but and the diversity in different landscape will be different, the diversity of insects. And if you are in natural areas, Apis mellifera is 1/3 of the prey spectrum, and social wasps 1/3, and Diptera 1/3. And the more you go to urbanized areas, more honeybees are the maximum, the higher in the prey spectrum. And we can say that Vespa velutina will hunt preferentially grouped insects with a peak in October. So it will be honeybees, social wasps, it will be scavenging flies or pollinators. And as the peak is in October, for social wasps, it's too late. It's the end of the colony, of the life cycle of the colony. Scavenging flies, it will hunt essentially very common species, and it will be only in mainly in honeybees that it will be an impact. So the impact is low for insect fauna, wild insect fauna. It can weaken other social species like bombus, but the impact is low, and it can also have an impact on late blooms of plants, only because it prey on flowers, and the insect doesn't stay too much in flowers, so it's not a good pollination. On the honeybees, we show that it was not the predation was an impact, but the number of hovering hornets. More you have hovering hornets in front of the beehives, more the colony will increase its activity. And we show that if there is higher than 12 hornets, you can have a paralysis of the colony, which lead to the collapse of the colonies. And next, only in France, we show that in each department, the density of honeybee will be different, the density of hornet colony will be different, and so the impacts would be different. We make a model, and we show with this that if we have the maximum density of hornets in all the French territories, in every place each year, which is improbable, we would have a risk of mortality because of too much hornet in front of beehives of around 30% of mortality, with a cost of 30 million euros each year. In fact, we made the survey in 2008 and 2019, and we show that today there is only 4% of mortality due to more than 12 hornets in front of beehives. So it's only mortality due to this intensive pressure, but it's not. We cannot consider the weakness of weakening of honeybee colony. And which is important is that we have only 4% of impacts of mortality, which could be reduced really easily with things we call muzzle. It's a mesh you put in front of beehives, and it reduces the stress, and you can maintain an honeybee activity of around 80%. I don't know where I am in the time, so. There is also other methods and many methods today which are proved to be efficacious, like efficient, like electric harps, and traps are becoming more and more selective. So we can hope that with all these methods, we will have soon less impact of this hornet on honeybee colony. And I finish there. I hope it was not too long. Thank you.
No, thank you, Quentin. It was interesting, and even I got some update data, so thanks for this. Now it will be Alain Goulnick. Alain Goulnick is a professional beekeeper from France, member of NOSAD, the Federation of the Association for the Defense of Honeybee Health, and he will present the field situation of Vespa velutina. So Alain, it's yours.
Okay, thanks, Cindy. Thanks all. Everybody. Good morning, good afternoon, everybody. So let me maybe put full screen here. So I'm going to present you the field situation in France for Vespa velutina. I'm doing this presentation on behalf of Etienne Calais, who is a major actor in the fight against this the species in France. So this is the same map Quentin was presenting, so I won't elaborate on that. So just from the beekeeping aspect, in 2004, when this Vespa was introduced in France, it was really a disaster, both economically, but also because there were some personal feelings about losing the hives against that predator. So everybody was unprepared to that. There was no plan, no help from authorities, no eradication plans, and by the 2014, half of the territory was covered. And now, after 20 years, everything is covered. So it was really hard because with no plans, we had absolutely, in each area, we have to discover what to do with this predator. And we can say that every area, and maybe sometimes every beekeeper, has to reinvent the wheel to find some solutions. So later on, in 2022, there was this plan proposed by Etienne Calais, so I was talking about him earlier, who proposed this plan, and the plan was proposed in 2022 in June. In fact, the first version was not really appreciated by beekeepers. Some frustration arose, and some critics also were formulated on that. So at the beginning of this year, 2024, a new version of the plan was proposed with more institutional actors that were brought up in this plan to propose maybe more practical solutions, because it was really that was missing in the first plan. So now, as of today, the deployment is ongoing. So there were three concerns that why maybe we needed to address in this plan. So addressing the colony health issue, meaning as Quentin explained, there was some really some loss in the colony. So that was needed to improve this health issue. Also, the impact of biodiversity was really a concern that we needed to address, and protecting people as well. I mean, citizens are also exposed to that to this insect. So the conclusion is that for the moment we cannot eradicate Vespa velutina. We have to live with it, and the only thing we can do is mitigate the consequences. So here the plan is in 3 parts. First, destroying the nest, then all the spring queen trapping, but also worker trapping later on the season can be done, and mechanically reducing beehive stress, as Quentin was explaining as well. So before doing that, the plan explained that we need to evaluate the risks. There is no, well, it's not very useful to do spring trapping or to reduce colony stress when there is very low hornet pressure in the area. At the opposite, when there are a lot of hornets that are present around the hives, it's very needed to do this spring queen trapping and reduce the stress. When it comes to nest destruction, well, we have to localize that, and maybe this is something that we don't know how to do. But anyway, when there is high pressure, I think it's also a best effort to do that, and maybe if there are some specific risks for the population, but generally we have to live with this nest around. So if we go through the calendar, so spring queen trapping is, I will detail that a bit later, but well, obviously it's during spring or early spring or late winter. Stress reduction is mostly during the end of the season, at the end of the summer. Detection is destruction is as much as we can, on worker trapping during the fall or end of the summer. So first axis spring queen trapping is important. It depends as well at the where you are in France, and also it depends on the weather, where and the advice which is given here is to do that for 2 months, no more than 2 months, but to start only when there are a few days above 12 degrees, 12, 14 degrees. Before it's not really useful, because the queen are not there, they are still hiding. And to see the effects of that, we need to do that every year for at least 4 consecutive years. There was some good results in the area named Maine-et-Loire in France. After a few years, there was really a reduction of the pressure after this 3 years. For the trapping, there are some concern about the biodiversity. So there is no perfectly selective or even efficient traps to catch Vespa velutina. So the plan provides some advice and recommends some kind of traps and some kind of baits to use. This is, for example, of the traps that are proposed. First of all, we need to have some cone trap. Also, we must separate bait on the catch cage itself. And a very important recommendation is to do not use bottle traps, which are really a big problem for all the other insects. And how many traps you put around your apiary, for instance, depends on the localization and the infestation level. The costs are high, so this has to be considered as well. And along to the trapping, it's important as well to collect and store data, which are useful to monitor the progress of what we do, and to have also some correlation with the infestation afterward. The second axis is nest destruction. So 2 steps. First step is primary nest. So quite easy to find in May, June, because generally they are on sheds or under roofs. So it can be easily found. Afterwards, the secondary nests are a bit difficult to find because they are generally high in the trees between July and October. And also, we have seen a few of them underground or in the bushes. The plan provides as well here some advice for the destruction, so they must be carried by technician or by professional at least. At least in France, only a few allowed techniques are possible. Even if there are some experimental ones, anyway, there are some limitation of what and when we can use. There are some good practices also that ask to the technicians, and specifically managing nests after treatment, meaning destroying them, for instance, and not letting the birds eat out of the nests. And there, storing data in parallel to the one for the trapping are very important. And the last recommendation is it's totally useless to destroy nests in winter because they are empty, and as you may know, destroying nest is expensive, so we need to definitely save money here.
Alain,
Yes?
I'm sorry because your time is already out.
Okay, so just to finish, we have put in place a governance system as well. So there was National Steering Committee with a working group to improve the plan as well. So as a conclusion, this is a new plan with pragmatic approach. There is no new techniques, but anyway, this is useful for all the beekeepers and all the population. The only, I think the only weak spot here on this plant is that there is nothing about nest detection. And I think this is something that should be improved. So even if not perfect, this plan is a big progress in the fight against Vespa velutina. Thanks, and sorry for having maybe been too long.
CD, you are muted.
We cannot hear you.
Okay.
No, so sorry. So it's me. I'm sorry because I have to keep the time. I can understand the frustration. So now let's move to Spain with Lourdes. Lourdes is a vet and she is advisor for the COAG. COAG is the Farmer Association and mainly the branch of the professional beekeepers. So Lourdes will discuss with us about the field situation of Vespa orientalis. So Lourdes, the floor is yours.
We cannot hear.
Good afternoon.
Great, thank you.
Good afternoon. And thank you for the invitation. I'm going to present the situation of another threat present in the Spanish territory, Vespa orientalis. But first, I would like to show you the experience with invasive hornets in Spain. In this slide, we see the 3 invasive hornets that have been colonizing the peninsula. First, velutina, Vespa velutina, entered the north in 2010 from France. In 2022, an isolated nest was observed in Los Barrios, Cádiz. We think it didn't spread due to our dry climate, and we hope it continues like that. The second, Vespa bicolor, established in the province of Malaga in 2013, from where it has not expanded. This hornet lives here without major incidents to society. The third is Vespa orientalis. An isolated female was found in the city of Valencia in 2012 and has been kept at bay until 2023, when it has spread to another places in the province. In 2018, it entered Cádiz by harbor and quickly spread to the entire province and to Malaga. The data you see is collected from the WASP map page, Mapa de Avispas in Spanish, a very practical online tool. This web helps to report in real time the sighting of wasps and hornets. Any of us take a picture and upload it to the page, indicating the date, place, and any observation we think is interesting. Afterwards, an entomologist identifies the species. At the end, we have a daily update of the sightings. The page has also information on the different wasps and hornets and very good pictures. We like it a lot because it's quick, practical, and visual. Vespa orientalis has adapted remarkably to the climate of Cádiz and Málaga. The hornet expanded widely in 2023, reaching Seville in the north and consolidating its presence in Málaga, capital, and beyond further to the east and to the northeast. Consequently, it has been opened the door to the center of Andalusia and other peninsular areas. In all these mentioned areas, the number of sightings has also grown, so it's clear the large increase in the orientalis population. To differentiate the orientalis hornet, we need to pay attention to three main features: its color, which is brown-reddish, the two yellow bands on the abdomen, and the yellow patch between the eyes. The biological cycle is very similar to other Vespids. Every colony begins with a single fertilized queen after her hibernation. She emerges at the end of winter and beginning of spring and looks for a place to build a nest. Nesting normally happens in closed and protected spaces, both above and underground. And this is a difference from velutina, who builds the nest high in large trees. This is why orientalis nests are more difficult to find. The queen lays the first eggs, and she feeds the first generation of larvae in this primary nest. That is to say, in this first phase, she is in charge of the entire colony. This makes this moment the most vulnerable for the population during March or April. The eggs hatch, and new individuals get in charge of building and defending the nest and carrying and feeding the young. So the queen will only lay eggs. The nest expands and the initial hole becomes insufficient. Therefore, the nest becomes visible. It could happen that they migrate to a different location and build a secondary nest. The size of the colony has an exponential growth rate. At the end of summer, beginning of autumn, more or less in September, the population is at its maximum level and greatest activity. Here, the queen lays the eggs that will give a rise to new queens and males. And this is the moment of larger damage to honeybee colonies and environment. In autumn, September, October, the reproductives emerge from their cells, they mate, and the decline of the nest begins quickly. In October, November, the worker males, late larvae, and the old queen die, leaving only the new fertilized queens. They look for protected areas to spend the winter and thus close the cycle. The duration of queen cycle is 7 months. Here you can see some pictures of orientalis and bees. The difference in size is quite remarkable. The infestation, if we can call it so, may get to intense level. A queen lays up to 4,000 eggs during the development of the colony. Adults basically feed on elements rich in carbohydrates, and in autumn they turn to reap fruits. The workers are predators or other insects to feed young. Therefore, it is an agricultural pest. It damages fruit crops, trees, and bushes for feeding on fruits and for collecting elements to build their nest. The hornets can also represent a public health problem, as its behavior is quite aggressive when defending its nest. Their sting is quite painful, and some people are allergic to their venom. It is also a problem for biodiversity because they predate honeybees and other wild pollinating insects, which are already scarce. Finally, they also damage beekeeping, same as for velutina. They weaken honeybee health, even leading to colonies' death. Predating rate of Apis mellifera is 33 bees per hornet per day. To have a legal tool with which to fight these species is necessary that it be included in the National Catalogue of Invasive Alien Species, included into regulation. After 3 years of effort, we finally achieved it. It was included in the catalogue, but it is not yet published in official regulation. Controlling the Vespa orientalis, like the velutina, can be done in 3 ways: trapping queens in early spring. The bites may be different than those used for other hornets. Nest removal or destruction. The nest could be, as I have said, even underground. Hive protection with electrical, chemical, or protective mesh methods. The objective is that the hive can work even under pressure from the hornets, so that the viability of the colony is not compromised. Here you can see 2 pictures of a sample of trapping and mechanical protection of the colonies. All trapping methods shown in this presentation are being tested to find the maximum level of effectiveness. Other control measures are networking with researchers and beekeepers from other areas affected, expert advice. We have established contact with 2 Spanish experts on the topic. We are establishing research collaboration with Córdoba University. And finally, we are making efforts on awareness raising of stakeholders so they understand the stake with this pest. I will stop here my presentation. I leave you with these pictures of orientalis attacking real hives, and thank you very much for your attention.
Yeah, thank you very, very much, Lourdes. It was on due time and very, very interesting. So now let's move from Spain to Italia. And this time we will have a duo with Laura Bortolotti, who is researcher at the Research Center for Agriculture and Environment of CREA. She is studying the relationship between bees, wild and managed, and their environment. And more important, since 10 years ago, she is the coordinator of the national network Stop Velutina. It's a very useful one, translated in many languages, which brings together research body and beekeepers association in the fight against Vespa velutina. She will do the presentation with Antonio Feliccioli, a biologist, associate professor at the veterinary science of Pisa University. He's teaching apidology for the student of the 5th year of the animal production. He has been working on Vespa velutina since 2014, when the hornet arrived in Italy, so 10 years ago already. So the floor is yours. I'll let you share your presentation. Thanks.
Good afternoon. Thank you for the presentation and for the invitation. I will update you on the field situation of Vespa orientalis and Vespa velutina in Italy, since as for Spain, we have both species in Italy, and both of them, as Lourdes said, are very harmful to bees, but they have in Italy a different status. In fact, only Vespa velutina is considered an invasive alien species, and so it falls under the regulation of the European Parliament of 2014, which was implemented in Italy in 2017. It foreseen, together with other measures, the main measure of surveillance, rapid eradication, and management measure. So I will update you on what we are doing in Italy for this. And regarding the surveillance, we have several platforms. Some of them are at the national level, like Stop Velutina, the network I coordinate, and the Livestock Vespa platform, and other are at transnational level inside the projects or organized by regional beekeeping association or veterinary services or university. And thanks to all this network, we were able to precisely map the movement of Vespa velutina in Italy. And as you see, we have a main concentration which cover all the two regions bordering with France, Liguria, and also a part of Tuscany. But we have also some isolated outbreaks, and this one we consider it as places where we can make an eradication, what we call a local or regional eradication, thanks to the neutralization and removal of the nest. And in some of these cases, we were successful in stopping the movement, the invasion at regional level. For what concerns Vespa orientalis, this species in Italy is endemic in the south, and so it's considered a native species, but in the last 10 years it is moving toward north, so in region where it was not present. So we considered it, we define it as a neonative species according to this definition, species that naturally spread in new areas favored by anthropogenic changes. And since it is also dangerous for bees, we are asking how to intervene in these areas. And the reports of the species at our platform are increasing year after year, and as you see, many of them in the red squares, they come from region where they were not, where it was not present originally. In Italy, we are setting up a network of institutions dealing with the hornets, where in the region where the one of the species is present, and in those where the two species are already present, like Liguria and Tuscany. And this was done to avoid the fragmentation of intervention and to define common protocols and measure on these hornets. Regarding the management measures, we have a national plan which was developed under the LIFE project, Livestock Vespa, and was released by the Ministry of the Environment. Regarding the management measure, I leave the floor to my colleague, Antonio.
So thank you. Can you hear me? So
yes,
thank you.
Yes.
So thank you very much for the invitation. And with Laura, we are sharing the presentation. So I will ask Laura to go forward with the slide when I just ask her to go on. Thank you very much in advance, of course. So high efforts have been spent to the primary nest removal. But of course, we need to detect them first and to be sure that the nest is belonging to Velutina and that the queen is in it. To remove these primary nests, we usually use alcohol, ethanol. Okay, so we can go on a little bit. The detecting of the primary nest need a net of people that are all prepared in order to make right signaling and very early signaling in order to make this effort. For the deactivation of the secondary nest, we usually use the carbon rods that are quite common with a permethrin carrier tube and a pump. Normally, the nest with permethrin inside is left in situ, and this is an environmental problem for all of us. because this is quite difficult to remove the nest from the hive where we can find them. We use a net of beekeepers that are all informed, and they are not, they do not have tools as trucks and something like this. So when we are lucky, we can use the fireman device. We can go on the next one. Thank you very much. This is the row. Okay, another one. Another one. Thank you very much. There he is. These kind of tools are able, sometimes, not always, to remove the nest. In this case, we are lucky because we can inspect inside and we can study the content. We can go on. So in this histogram, you can see the progression of the next detection from 2019 to 2023 at its invasive border in Tuscany. And we can go on. And concerning the 2023, we can see that the match number of the nests that are detectable always is in the autumn, and when the leaves are not there, and it's much easier to detect them. And Alain said that it's not useful to destroy nests during the winter, but in our case, at our latitude, unfortunately, also this year, during all the winter, all the nests, most of the nests, sorry, were still active, and hornets were flying out and inside also in this January 24. We can go on a little bit. So the important thing that we keep in mind is the green part of this histogram, that is the not reachable nests. So they were active, but they were not reachable. So if we keep in mind the dynamic of the population and the explosion of the nest that starts in Italy and now is at the border in Tuscany, is growing up, only leave this nest there is, of course, make this kind of work. We can go on a little bit, and again, another one. And, oh, sorry, you can see here the maps of the unreachable nests, and they are quite the same area where all the other ones were detected. So, of course, this became a very Sisyphus, as you call the Sisyphus fatigue. That is emerged also in the first relation that we had. Okay, so what we can do is just to try to integrate with different approaches, the infrared camera, and we can go on, or the radio telemetry, and we can go on again. And but also we can try to hope in nature, and in early season, in early years, we found and we detect, we can go on, some pathogens, as the deform-wing virus that affected, and also Kashmir bee virus that affect these velutina hornets, but they were not symptomatic. But we can go on. During 2022 and 2023, we found several hornets with deformed wings. They are all the fridges, and we need to ascertain and to be sure that is the VUVU and which kind of genome of the three that we know. And so we will need to make some PCR on this. We can go on. So thank you very much, and I give back to Laura in order to try to find this new way, that is to destroy nests without knowing where they are. Thank you very much.
Thank you, Antonio. This is the very last slide. In Italy, we are testing a method. We call it the Z method. The Z is because it is the last frontiers of the possibilities. And this method uses a patented device to contaminate hornets, and then they are released and they go back to the nest, resulting in the nest neutralization. The method I underline is not currently approved by law, but we get a provisional authorization for research purposes, and we tested it in the last year, and it has proven to be effective. So we are trying to find the legal way to apply it on Vespa velutina infestation. Thank you very much for the attention.
Well, thank you for your presentation and also for keeping the time. So now I will give the floor to Nigel Simmons from UK, from a governmental agency. He is a contingency planning officer for the National Bee Unit, which is a part of the Animal and Plant Health Agency in UK. And he's going to present us what is done in UK to try to control Vespa velutina. So Nigel, the floor is yours.
Now, can you hear me?
Yeah, we can hear you, but we cannot
Super.
see you.
You can also see, or you cannot see me.
Okay, no, we can.
Can you see my presentation?
Yeah, we can see your presentation.
That's the most important bit. I'm famous for overrunning, so I'll try and do this at speed, and my apologies if I do. So I shortened my title to match with the other titles, so we can talk about Vespa velutina in the UK. Our strategy, and we have a contingency plan like many of you, is currently one of preventing establishment stroke eradication. We have a government-led and funded response funded by the Department of the Environment, Food and Rural Affairs, and a whole, I will not go through each line on here as time is limiting, but a whole number of agencies, governmental and non-governmental, are involved that participate in this and enable us to do our current eradication methodologies. We also have a growing involvement of stakeholders, beekeeping associations, and I will not mention them at the start, but at the end, it's very important to say they are very important for the monitoring both before and afterwards, and help us greatly with this response. Since our first nest was in Tetbury in 2016, and we've had on average 2 nests a year since then up till last year. We believe there's no evidence of an established population at that point. All the surveillance afterwards has shown these to be individual nests, or where there's been both a primary and a secondary in the same spot. But no surveillance has ever shown nests in subsequent around the area in subsequent years. And we have a great deal of surveillance, as you'll hear in a moment, going on in the country. In 2023 was our nightmare, if you like. We had 72 nests in 56 locations. If you look at the big map, you'll see they're mainly spread around the coast. So our belief is, and I'll come on to the genetics in a moment, is that these are all separate ingresses for mainland Europe, and they've mainly come in via the ports. If we focus into the main area, which was in Kent, as you can see on the right here, they were mainly spread up the main routes that have come across for transportation via the ports, the tunnel, etc., and then up the motorways where all the lorries, containers, etc. go. At this point, it is only Dover, which is in the right-hand corner here, is only 32 kilometers from France, and there's obviously a huge range of boats, etc., for hitchhiking and other vehicles as well. All our sightings are triaged by the UK Centre for Ecology and Hydrology, and we mainly use an app for that, the Asian Hornet Watch app. There are other methods, but that's the key one. In general, we get about 10,000 sightings a year. But last year, because of all the publicity that I'll mention in a moment, we went up to 20,000 sightings. But please, these are not all Asian hornet. Less than 1% are Asian hornet. The majority are misidentified insects, and this compares greatly to other countries like in Jersey, where Asian hornet is, where their sightings are up in 70–80% of sightings are Asian hornets. So it's very, very low. We follow up on all the positive sightings that are confirmed. We do track and trace under the invasive species licensing from Natural England. This hornet has a bit of tinsel on the back of it, but often we use on the back of them, much like in beekeeping. We have an app we use for the track and trace that allow the inspectors on the ground to follow the lines of sight without being in radio contact with each other, so they can see that all live. And we normally track the nests in 1 or 2 days after we've had a confirmed sighting. Our nest destructions are used using a pyrethroid permethrin. We use air lancers like was described earlier. We bring in cherry pickers to both aid in the process of destroying the nests and in the removal. All nests, where possible, are removed and taken for analysis. We have 14 APHA staff currently trained in this methodology, but we're building on that all the time. And we use tree climbers from a framework agreement we have in the rest of the agency. Very importantly, every single hornet that's collected in this process is barcoded, not on the hornet, on the tube, and sent for analysis up at Ferra. And the same goes with every single nest. So they're all collected, all removed where possible, and then sent for analysis. The preliminary results at the moment is all, as I said, 72 nests, all nests killed last year. 3 nests were unretrievable. They were in roofs where we couldn't get into them. They were still killed. But 4,605 hornets analysed, all by microsatellites. So they're all compared to the nests in that area. And this is absolutely key, and I'll talk about why in a moment. We had 58 separate queens, so we had 44 singleton nests and 14 primary secondary pairs. And most queens in the nest had mated with only 1 drone. We believe, no clear evidence for an established population, but we keep reviewing that every year when we keep this analysis ongoing. On this map on the right, you will see the little blue zones are 5-kilometer zones. And these are around the nests that we believe have got to the stage of producing queens last year from this microsatellite analysis and from the analysis of the nests. And they are our risk zones at which we're doing some spring trapping this year. And very importantly are our beekeeper associations. The British and Welsh Beekeeper Associations are the main one. They have set up Asian hornet teams, and this is a small portion of their map where the public can contact people. When I talked about all the sightings we had earlier, when we have a sighting that is unconfirmed, we send a link to this so the member of the public can contact the Asian hornet team and have someone come up and confirm that it wasn't an Asian hornet in their area and tell them how to identify it. And they are doing a huge amount of raising awareness after the nest last year. They paid for buses to have Asian hornets on the back of them all over the south of England. They are doing a huge amount of raising awareness this winter. This was the National Outdoor Expo, had a giant Asian hornet wandering around at it. And they're very important for our wider monitoring during and after a response. And I hope I've kept roughly to time, and thank you.
So thank you very much, Nigel. So just to try to summarize a bit, so we can see that Vespa, both orientalis and velutina, are impacting beekeepers, but not only, also the biodiversity, and there's a risk for citizens. And the beekeepers are key actors or stakeholders for monitoring and raising awareness, like Nigel just said. I didn't see a lot of questions in the Q&A, but actually I have some. I would like, for the country like Sweden or Austria or also United States, which would like to be ready for the invasion, if you have a kind of advice in some keywords, one of you. And then a question for Laura about this Z method. I'm really eager to know more if the publication is going to be published soon, and the device release, of course, because I know that beekeepers, they are waiting for solutions. And also, if there's someone in the audience, you can put your question in the Q&A. We'll have a look. So if someone wants to answer.
In fact, there are more questions in the Q&A session, asking for the bottle the bottle traps also, some other suggestions as well. So if one of the speakers can answer this question, it would be good. And what about the Z method? Laura, would you like to elaborate a little?
Yes,
Now,
of course.
maybe because it's you're
I
already
was
online.
Yes, I was looking also to the question in the chat. So the Z method use an insecticide. Actually, it is a neonicotinoid. I know this is a very dangerous for the environment pesticide, but the amount that is used is very small comparing to the amount that are used in farming, in agriculture. And of course, now it is at an experimental level. If this molecule will be registered for wasp, for the use on wasp and hornets, because until now it is not registered for this kind of animal, but only for other animal like ants and cockroaches. And it will undergo a registration procedure that include also an environmental measurement of the impact. So for sure, it will not be released if it's dangerous for the environment. Until now, we made only a test on its efficacy and not on the environmental danger. We are, of course, trying this procedure, but it is a chemical industry, a chemical farm that is in charge for the registration. So what can we do is only to make the test to demonstrate that is not harmful. What I can say is that in the apiaries where we applied, there were no damage on bees at all. But for sure, the nests are not found, so the insecticide remained in the nest. But as Antonio Felicioli said, this is also what happened very frequently with the nest treated with permethrin. So I think it's not more dangerous than the approved method of nest neutralization. I don't know if there were other questions about that. If so, please tell me about that method.
No, for me, I would say it's okay.
Well, there are still several of the questions in the chat, not in the chat, sorry, in the questions and answers. So if the speakers can go through and give some answers.
Oh, there is one in Italy. Oh, sorry, Fanny. I saw the one, why Vespa velutina is only found in coastal areas. I think this is a climatic preference, but now it is moving also to in other area inside the country, and also in very high in like hills or mountain, what was unexpected for us, because usually we know that up to 1,000 meters it does not survive, but now it is climbing the Apennines, and so probably the climatic change favored moving also towards other areas. But of course, the coastal areas are more suitable.
Yes. CD, are you okay with the session? Can we move on? Because we are already 5 minutes past.
I think we have done. So thank you. Thanks all of you to the speaker.
Thank you, CD, and all the speakers of this session, but we can always have the general discussions at the end. And the subject of the climate change and how this can really affect the species that they are not invasive in the countries, like it was with Vespa orientalis in Italy. It's also in my country, in Greece, in the south, but now it's in the north. So you can see the direct effects. Could we move quickly to the second session? And I would like to call Giovanni.
Hello, hello, Fanny. Hello, everybody.
Thank you, Giovanni.
Hi. So, hi, everybody. So now we have the session about small hive beetle, Etina tumida. We will have presentations from 4 experts. 3 are from the European Union and 1 from the US. So let's start with Dr. Mark Scheifer. So Dr. Mike Scheifer graduated as biologist in 2004 at the University of Würzburg. Afterwards, he started his doctoral thesis, which he finished in 2009 at the University of Bern in Switzerland. From 2010 to present, he is head of the German National Reference Laboratory for bee diseases at the Friedrich Loeffler Institute. He has been involved on several research activities on small hive beetles and Varroa mites, and on methods for diagnosis, pathogens, and parasites of the honeybee Apis mellifera. From 2017 to date, he is designated expert and head of the WOA reference laboratories for American foul brood, small hive beetle infestation, Etina tumida, and varrosis of honeybees at the Friedrich Loeffler Institute. Please, Dr. Scheifer, the floor is yours.
Thank you, Bart. Thank you, Giovanni, and thank you very much for the invitation. So I will give a very short overview of Etina tumida in Europe.
Mark, you're muted. Mark, you're muted. Somehow your mute went back on, Mark.
Okay, sorry. So now you can hear me.
Yes.
So the small hive beetle has the size of about 5 millimeters length and 3 millimeter wide. And with this, it is about 1/3 of a worker honeybee. So the small hive beetle finds the honeybee nest, and inside the nest, it will try to reproduce. Like there's some characteristics of an adult beetle that allows you to distinguish it from other beetles. Like I said, it's a brown blackish beetle. It has a club-shaped antenna, and its elytra are so short that a part of the abdomen is still visible. So when it's able to reproduce in the colony, it will lay its eggs, which are about 2/3 of a bee egg. And if the conditions are good, the larva will hatch, and they will feed on honey, pollen, and the brood, and it will grow in about 1 week to 1 centimeter size, and it will leave the hive, calling the wandering larva. And those larvae have also some characteristics. So they have like 3 pairs of long forelegs, 2 large spines protruding from the rear, and a row of spines on the dorsal side of the larval body. So Etina tumida managed actually to reach to many different places in the world, like you can see on this map. The dark red area is the endemic distribution range in sub-Saharan Africa, but it already has a lot of other established populations. And the latest introductions were La Réunion in 2022 and Tasmania in 2023. So what are the possible pathways of small hive beetle introduction into new countries? So there are some indications that discuss the international wax trade as an important pathway for small hive beetle. But also the trade with queen bees might be a very frequent cause. And furthermore, there's also trade with package bees and there's trade with bumblebees. So small hive beetles are attracted to all the things you can find in a honeybee hive, and they are very similar to bumblebee hives. That's why bumblebee hives could be also very attractive for small hive beetles. But not only with this bee introductions or bee trade, there's also a possibility that it's an accidental introduction, maybe on goods that have nothing to do with bees at all, like ripe fruits or maybe plant soil, because the development from the larva to the adult beetle is actually in the soil. And what can also happen is that you have a swarm in the container. So in Europe, the small hive beetle arrived first in 2004 in Portugal. They were found among accompanying bees in queen cages, and the import came from Texas. Immediately after the positive result, all of the supplied material was collected and all the colonies were killed and burned. Afterwards, the topsoil of the apiary where the queens were introduced was removed and deep buried into the ground, and a foil was put over it. And with this immediate measures taken in Portugal, the further spread was actually successfully prevented. But in 2014, it arrived in South Italy, in Calabria. So actually on September 11, the first detection of small hive beetle was found in a bait trap, actually, in the town of Tauro, which is very close to a very big harbor. And it's all in the province of Reggio Calabria, which you can see on this map here. And in this year, 2014, there were, I think, 58 apiaries were burned, altogether about 3,200 colonies, plus 2 sentinel honeybee nuclei and 1 infested natural colony, so a wild swarm. And there in Calabria, it seems to be established, because until now we have beetles here, but we will hear about it very soon. And then, like I said, before Tasmania, it arrived in La Réunion. La Réunion is far away. It's actually an island in the Indian Ocean, but it is an overseas department and region of France. So it also belongs to Europe. And there it's a small island. You can see the 10 kilometers on the left corner. So it's not very big. But in 2022, only the south of this island, actually in the region Saint-Philippe, was infested by small hive beetle. But as they already found it in the first year also in natural colonies, so these are actually the pink dots on the map, while the green dots are apiaries. And so if you find it in a natural colony, it's actually impossible to eradicate. So they actually have a management plan that they try to manage the beetle but without eradication. So they try to contain it in this area. And just 2 example pictures of Saint-Pierre, where the first beetle was found on La Réunion. So this is a typical apiary in Saint-Philippe. The area is very mountainous, and there are many apiaries inside the subtropical rainforest, and they are all not easy to reach. So like eradication would be also not easy there. And it's a volcanic island. The soil is only very thin on top of the volcanic stones, but still also this very limited amount of soil seems to be enough for a small hive beetle to reproduce. So how can we slow the global spread of Athena tumida? The key is early detection. So we can have early detection if we have an import control, if we have stakeholders that are aware of this new parasite. And so we have to educate those stakeholders. And it would be good to have a contingency plan in place before the beetle arrives, And this also includes sentinel apiaries to catch the beetle at harbors, for example. So if it's detected, we have to think, is it still an early stage like it was in Portugal? Can we still eradicate it? Or should we try to contain it in this area? But doesn't matter what we do, we need to continue the monitoring after we have first found the beetle in a country. If you want to read about this, you can read in this Colors Small Hive Beetle Task Force publication. And with this, I would be finished, and I will answer the questions later after all the other talks. Thanks a lot.
Thank you very much, Mark, for this nice presentation. So let's proceed. If Franco agrees with Franco, as Liliana is solving some technical aspects. Franco, is it okay for you to make your presentation, or just let me know, okay?
Yes, it's okay. Good afternoon, everybody.
Thank you.
I just try to share my screen.
Okay, we see the presentation. Thank you, Franco.
This full screen. Okay, good afternoon. First of all, I would like to thank you, the organizers, to invite me to contribute to this seminar on invasive species in Europe. As said by Mark, Calabria region was the first territory of the European Union where small hive beetle has been detected, and I start with the map that with the map that Mark showed, presenting the location of the first detection of small hive beetle in Calabria region mainly, and an outbreak also in Sicily region. This was the end of 2014, and in figure with letter B, we have the picture of the situation at the end of 2022. We still have infested apiaries in Calabria region, in the province of Reggio Calabria. And in this map, you can also appreciate the sentinel honeybee colonies established both in Calabria and Sicily. They are represented by the violet dots, and the green dots are the apiaries that have been the target of small hive beetle surveillance. And you can see the intensity of this surveillance activity mainly in the Calabria region, northward to the infested area. And in the figure with letter C, we have the situation at the end of 2023, and we still infested apiaries in the same area where they have been detected already 10 years ago.
It's breaking.
Okay. Now, a quick summary of the measures adopted by the central competent authority, together with the local competent authority and the national reference laboratory for bee health. The measures were those of eradication and/or containment of the infestation. These measures are still in force in areas not yet infested by small hive beetle. And the first measure implied immediate notification, a restriction of any movement related to any bee colonies, and the verification of the registry, the regional registry of apiaries and colonies. A protection zone was established with a radius of 20 kilometers where all apiaries were visited, and also colonies were visited according to an expected 5% expected prevalence. The consequence of the detection of small hive beetle was the application of restriction measures to the apiaries and destruction of the whole apiary and compensation to beekeepers. Traps was also applied, and traceability of commercial and migratory movements in and out of the protection zone was applied. Starting from 2015, sentinel honeybee colonies have been established, and these colonies were under direct supervision of veterinary services. This means that they were established by veterinary services and periodically controlled by veterinary services. These sentinels are still in place today, and they contributed to the surveillance, and they contributed to providing information about the circulation of the small hive beetle in the affected territories. We established also a surveillance zone that was extended outside the protection zone, and this surveillance zone corresponded to the remaining territory of Calabria region and to the remaining territory of Sicily region. And also in these territories, in this surveillance zone, apiaries were checked, and also colonies. Over the years, the regulation was revised, and this is the relevant change that was approved in 2019. And at that time, the concept of selective stamping out of colonies infested with larvae of Velutina tumida in the protection zone was accepted and was approved. And since then, we stopped the stamping out of the all infested apiary. Another point that should be remarked is that movement of colonies was demonstrated to be responsible for the onset of new outbreaks, and this is the list of the outbreaks that have been demonstrated to be related to illegal, unauthorized movement of colonies from the protection zone toward the surveillance zone. And here we have also movement within Calabria between infested and non-infested territories, but also from Calabria to Sicily, as it occurred in 2019. The measures adopted by Italian competent authorities were in line with the measures adopted at EU level, and this is the last decision dated 2023. There is a list of goods that cannot leave the infested territories towards the remaining territory of the European Union. And this restriction went together the needs of a strict surveillance of apiaries and epidemiological investigation, followed by reporting, periodical reporting to the Commission. As of today, the measures adopted limited to Calabria region the presence of small-eye beetle, and Calabria region is the only territory still subject to emergency measures, while Sicily is no more under restriction since 2021. Also, local regulation have been updated, and this occurred in 2021 in Calabria region. The map just to show you that the measure adopted have been able to limit the presence of infested apiaries mainly in the original area where small-eye beetle was detected, even if some outbreaks have been recorded in the rest of the territory of Reggio Calabria region. This is the situation as of today. Positive infested apiaries still present in Reggio Calabria region. This means that surveillance is still continuing, and the last tool, the last measure is the surveillance program at national level. So not only Calabria and Sicily regions are under surveillance, but also the rest of the territory of Italy. In the figure with letter A, we have the results of surveillance carried out targeting non-migratory apiaries, while figure with letter B, this is the result of surveillance carried out on risk-based selected apiaries, mainly migratory apiaries. And until now, no detection of small-eye beetle has been reported outside Calabria and Sicily regions. And I thank you for your attention.
Thank you very much, Franco, for your presentation about the spread of small-eye beetle in Italy. So let's go ahead with the presentation of Professor Jamie Ellis. And let me introduce Professor Ellis. Dr. Jamie Ellis is the Gahan Endowed Professor of Entomology in the Entomology and Nematology Department at the University of Florida. At the University of Florida, Jamie has responsibilities in extension, instruction, and research. Currently, Jamie and his team have over 30 active research projects in the fields of honeybee husbandry, conservation, and ecology. Please, Professor Ellis, the floor is yours.
Thank you all so very much for joining today. It's really my pleasure to be able to speak to you. I've actually been asked to speak about two topics, one of those being managing Athena tumida, and the second, the Colos World Honeybee Health. I have 7 minutes. I'm going to do these both in 7 minutes, so buckle up and hang on. We want to kill small hive beetles. We want them dead. We like our bees. We don't like beetles. We've had small hive beetles in the United States for over 20 years now, 25, almost 30 years, I believe. And I just want to share with you briefly how beekeepers have tried to manage them here and strategies that we're looking at more so in the future. When small hive beetles were first found, these two chemicals were the ones that became available for treatment in colonies, the first of those being check mite on the left that goes in hives, the second of those being guard star that goes on soil around the hives. Fortunately or unfortunately, neither one was particularly effective, so that caused beekeepers to take the next step, which was to develop home remedies or off-label uses for small hive beetle controls. I wish I could tell you differently, but this probably represents the most common way beekeepers control small hive beetles in the US. It is an off-label treatment. It is illegal, but nevertheless, it's very common. And so these roach baits or ant baits are placed into these pieces of plastic and the plastic is folded and taped such that small hive beetles enter the holes, eat the bait, and die. The reason commercial beekeepers use it is because it's quite effective, but again, it's an off-label use. Myself and colleagues have been looking for new chemical control strategies for small hive beetles. I'm not really going to talk much about this research project, except to say that many bee scientists here in the US as well as around the world are looking for safe chemical control options, chemicals that both have significant activity against beetles, but also limited activity against bees. That's the holy grail in regard to beetle control. There are many trapping options. Some beekeepers, especially hobbyists and sideline beekeepers, spend a lot of time trying to trap beetles. I'm not going to give you an exhaustive list of traps. I just want to show you a couple of styles. These are the better beetle blasters. There are lots of traps. There are bottom board traps, traps that hang between frames. There are traps that are composed of pieces of cloth-like material that when the bees fuzz those traps up, the beetles can get stuck in. There's just many, many, many trapping options. If you purchase, if you get one of our beekeeping equipment supply catalogs, there's usually a handful of traps available for small hive beetles, and it seems there's new ones developed every day. There are some cultural control strategies. For example, when we're using pollen substitutes, we don't just squeeze those pollen substitutes between boxes. We use these wooden frames that go around between the boxes, which creates a space to allow us to use pollen subs. And that extra space means the bees can patrol the pollen subs and keep those beetles off of them. We always endorse using good hive equipment. That picture of a beehive on the right is not from a beehive in the United States, but it does illustrate many, many different entry points for beetles into those nests. Another thing we focus on is management of small colonies. You see in the upper left pictures of mating nucleus. Mating nukes that we have here in the US, each of these will produce a queen. Those are very, very big targets for small hive beetles that can overrun those small, stressed out colonies significantly. So beekeepers ensure that there's many bees placed on those colonies on a routine basis. There's been some efforts looking at genetic control. We know beetles will oviposit and cap brood cells, and colleagues and I have developed strategies to monitor colonies' ability to detect beetle eggs and larvae and remove them from the nest. So genetic control and even biological control may be long-term options. For example, fungal pathogens or nematode pathogens, specifically nematode pathogens that have been tried in multiple places around the world. But honestly, the best way to control small hive beetles that you'll hear with regularity is control the diseases and pests that you can control, and that allows the bee colonies themselves to minimize small hive beetle damage. So as I segue from beetle control into World Honeybee Health, I'll just spend 2 or so minutes on this. Colleagues historically have been trying to map the spread of disease and pest around the world. That was first started by Nicola Bradbear, followed by Andrew Matheson, Mark Allen, Brenda Ball, and then I was able to pick up the torch with Pamela Munn in 2005. In 2020, colleagues and I published this paper as well as this website where we are trying to track the spread of diseases and pests around the world. And that project was inherited by Colos, who now runs this World Honeybee Health Task Force. I would encourage you to consider being a part of this task force. It's just our effort to keep track of where diseases and pests are. I know that there are efforts that mimic this, perhaps Apimondia or OIE or others, but we are trying to make this the global source for the spread of honeybee diseases and pests in real time. And the way that we're trying to do that is we have established regional coordinators who map these pests and diseases in their areas. I invite you to be a part. Why would you want to be a part? Well, it allows you to, be recognized as a local expert or regional or national disease and pest, a go-to expert, help us map this to limit the spread of these diseases and pests and fight for bee health. Most importantly, that last bullet point, though, is it allows you to hang out with cool people and have lots of fun. So I think it's really important to help with bees. If you are interested in joining this task force, I'm showing you here on this slide the contacts. Umberto Boncristiani and I are chair and vice chair. We have multiple regional coordinators. Please take your camera out and take a picture of the slide. because it provides a really good way to get a hold of us. We can include you in this effort, and it would allow us to do things like monitor the spread of small hive beetles. Unfortunately, I'm not able to stay with you much longer in this meeting, so I strongly encourage you to take a picture of this slide. If for some reason I'm unable to be here and answer your questions, if you'd like to know more about small hive beetle control in the US, I could talk for days about that. So please email me. You see my email address on this picture. If you want to know about Colos's World Honeybee Health Task Force, please also reach out to me. I would love to incorporate you in our efforts. And that is exactly 7 minutes. So I am going to stop, and thank you so much for your time and attention. Please reach out to me if there's anything I can do to help you.
Thank you so much, Professor Ellis. So if you have to leave, probably, can we ask some questions to you before you leave? Or
please, I'd be happy.
Yeah.
If you have a question or two, I can try to fill them.
Okay. So please, guys, take the opportunity to ask questions to Professor Ellis if there are questions. Otherwise, I already have one.
Okay, Giovanni.
So my question is about sustainability and about the use of chemicals for the small hive beetle. So I want to ask you, do you think, considering your experience and that it's so many years you have small hive beetles in the US, is it possible to control small hive beetles without using chemicals like fipronil, neonicotinoids, coumaphos, etc.? And
yes,
why beekeepers use chemicals? Thank you.
Yes. So a couple of things to say in that regard, and I'll try to be succinct. I will say the vast majority of beekeepers I know, those being hobbyists, right? Because we have a greater population of hobbyists than we do commercial beekeepers. The vast majority of beekeepers I know do nothing to control small hive beetles. Out in our backyard, we have probably 50 colonies here at the University of Florida. We have no beetle controls in those colonies, and we will not try to control them at all this year. Only when we see beetle populations going up might we put in traps. Commercial beekeepers, on the other hand, who manage thousands upon thousands of colonies here, run great risk because occasionally they'll have weak colonies or dying colonies that can be magnets for small hive beetle population explosion. So they often feel that it is necessary to keep those populations low so that they won't cause problems in their honey house or destroy their mating nukes, etc. So they continue to control it. But I want to be realistic here. Small hive beetles are nowhere near as damaging for us as Varroa is. And they're all, compared to Varroa damage, they're almost a minor nuisance. So they do kill colonies every year, but commercial beekeepers do continue to try to control them just to stop those explosions in their mating nukes or in their small nucleus colonies.
Wonderful. Thank you very much. And Fanny, have you seen if there are perhaps other questions from the chat?
Well, there are a few that they were posting just now. Fleming, please show the slide with all the contact addresses again. Who wants to show taking a picture? I think that was for Jamie.
I will do that. Let me quickly do that. Let's see your share screen. This is just for you, Fleming, because I like you so much.
And there is the last one says, is it the yeast that the small hive beetles are attracted to in a weakened declining hive?
Good question. So there is a yeast, Cotomia omeri, that has been found to be associated with small hive beetles. And when it is deposited onto pollen, it does produce chemical signatures of alarm pheromone. And the late Peter Till, who was a USDA scientist here in Gainesville, actually, and colleagues, Baldwin Torto and others, discovered that small hive beetles are attracted to the volatiles that this yeast produces. So yes, it is possible that that yeast plays a role in attracting small hive beetles to weakening or dead colonies or dying colonies.
Okay, thank you very much,
My
Jamie.
pleasure.
Thank you again. And so let's allow me to introduce you the last presenter, that is Liliana Cirillo. Liliana Cirillo is a beekeeper and beekeeping technician of the Aprocal Calabria Association. She has been a beekeeper for more than 10 years. She has a beekeeping company with 250 hives and produces honey of different botanical origin. In 2016, she joined the APRO Calabria Association, that is the Professional Beekeepers Association of Calabria region, as bee expert. Since 2018, she has been a member of the Technical Reference Center for Beekeeping of UNAPI, that is the National Union of Italian Beekeepers Associations, and collaborates with the National Honey Observatory as a professional expert of the monitoring network for the Calabria region. So, Liliana, the floor is yours.
Yeah, okay, just one short message. We have set up a weird technical solution and I hope that works, but she's going to talk through my microphone. Can you see the presentation that I shared?
Yes, thank you very much.
Okay, then Liliana, go ahead.
Good, thank you.
Okay. Good afternoon. As an apical technician, I would like to thank you also on behalf of our association for inviting us to talk about Etina tumida. Next. I live in Rocella Ionica, a small town located 10 meters above sea level in the province of Reggio Calabria. Unfortunately, I have had first-hand experience with this small beetle that has infested several hives in Calabria. I speak not only as a technician, but also as a beekeeper. The arrival of an alien pest in our region has disrupted the activity of beekeeping in Calabria. Next. In 2014, that Etina tumida landed at the port of Gioia Tauro, infesting several apiaries in the province of Reggio Calabria and Vibo Valentia. Efforts were made to deal with the enemy from the outset by taking various preventive measures. Reggio Calabria and Vibo Valentia beekeepers were prohibited from nomadizing in the rest of Calabria. Next. In addition, they have isolated the entire region to try to eradicate the small beetle, a ban that is still in effect. This means that no beekeepers in Calabria can leave their region to bring bees to other regions of Italy, and beekeepers in the rest of Italy cannot bring their hives to Calabria. This problem has severely penalized the Calabrian beekeepers in many ways, from banning the sale of the swarms and the queen bees outside the protection zone outside Calabria, to the freedom to go nomadic with their bees to go in search of other blooms. I will not describe the biological cycle of Etina tumida. Surely you are already aware of it. I just remind next of you that it is native to South Africa, belongs to the Nitulidae family, and is considered an opportunistic pest. Next. In 2014, the European Union, legitimately concerned about the spread of Etina tumida, asked the Calabria region to implement drastic measures to avoid an alleged catastrophe in the beekeeping world. The president of the Calabria region issues regional law number 94, devastating several bee farms and millions of bees which will remain in effect until 2019. Next. If Etina tumida was detected in one hive, the whole apiary had to be burned. The compensation paid per hive was €3,145. Unfortunately, there were multiple spares. More than 9,000 hives were burned. Almost €3 million was disbarred for the loss. What can be solved? Nothing. Nothing that the epidemiological situation has continued to persist and not solving the problem, as Etina tumida has acclimatized to our territory and become endemic. Next. In 2019, the Ministry of Health deemed it appropriate to review the strategy of intervention against Etina throughout the country. It enacted number 2 articles of law and an annex. Article 1 defines protection and surveillance areas. Next. Article 2 introduces new strategies with selective culling limitation of disruptive approach in apiaries infested with Etina tumida. First step in transition from eradication to containment measures. In the end, with the next one, brings the possibility to the veterinary service to destroy apiaries abandoned or not registered in the bee database, preventing the creation of abusive location and movements. And it is mandatory for beekeepers to use mechanical or biocide traps in all hives, under penalty of seizure of the apiary until non-compliance is resolved. Next. The presence of the small beetle in Calabrian hives, and in most cases of adults, is very much influenced by the climate, prefers spring and fall temperatures, humidity. But with the climate change we are experiencing, it can happen to the small beetles even February, talking advent of the hive height. Next. Aprocal frequently updates beekeepers on the Aetina tumida problem as soon as there is news on regulation. Next. And it disseminates good beekeeping practice. To save money, most beekeepers adapt to small beetle control with polycarbonate traps. Next. It has become essential to use queen excluders to prevent the queen bee from getting on the honeycombs. It benefits the quality of honey products and slow down the risk of Aetina tumida going, which, as we know, is strongly attracted to the brood. Next. The good beekeeping practices activity carried out by Aprocal was also a reminder to always keep the bottom clean or remove them altogether from the period of May until November. Since it is assumed that the small beetle is able to lay its eggs on the dirty bottoms and probably at the time of egg hatching. The larvae are able to feed on surrounding pollen. Next. The use of diaphragms to combat bees on well-attended combs and the removal of excess combs. The benefit comes both from making it easier to visit to clean out the cells from Aetina tumida of opposition and from facilitating better temperature balance within the hive. Next. Remember the utmost cleanliness of the feeders. Next. And medium to large farms equip laboratories with cold rooms, both to keep the honeycombs away from Aetina tumida, but also from Melonella or wax moth. Next, finally, with this I conclude. I would like to say that despite this endemic situation, the Calabria region is the fourth region in Italy for the number of hives, over 150,000, and honey production nationwide is about 9%. Next and next. Thank you for your attention.
So thank you, Liliana, and thank you all for presenting these very interesting slides on small hive beetle. So allow me to leave the floor to the president, Jeff Pettis. So I think they are glad to go ahead with the third session, and excuse us if we are a few minutes late.
Thank you, Giovanni. Actually, what we're going to do is take almost exactly, we had scheduled in a 10-minute break. We're going to take almost exactly a 5-minute break, and we'll leave everything active, but we'll resume at 15 after the hour. So, and to those of you who are asking questions, we will try to capture those from the chat and put those together in some question and answers after the event. And we will be able to post this online. So if you have colleagues that were not able to attend, we'll have this recording available on our website so we can refer to it again. But we're going to take, in fact, now a 5-minute break, and we'll resume at 15 after the hour. So thank you to all the speakers so far, and we look forward to concluding in the next session. Thank you, Giovanni. Yep.
Thank you. Thank you.
We'll be right back. We'll be right back.
Hey, Fanny, I'm just testing out my mic. Can you hear me? This is Jeff with a G.
Hi, Jeff. We can hear you. Yep.
Okay, perfect. Thanks, Jeff, with a J.
Yeah.
Hi, Jeff. I also have a question. And do I have to send my PPT to you, or do I upload from my side?
You upload from your side with the share screen option. So down at the bottom
Okay.
of your thing, you see a green share screen. So when it's as soon as let's see, as soon as Jeff Williams ends, then he'll stop screen sharing, and then you can bring yours up as I introduce you. So yeah, share it from your side, and then you have that way you have the ability to advance the
Yes.
slides that you need. Yep.
Okay, thank you.
Yep.
Hey,
Thank you.
Sorry, I have a question too. I would like to see if I can. Oh, I see. I can probably also share a screen.
Yep. Yep. From the bottom of your screen. Yep. And
Yeah,
again,
I see it now. Yeah, I see it now. I was worried a bit, but now I see it.
okay, well, good. This is good to hear. Now we're all, I've heard all four of our speakers, myself and the other three, so we're good. We're ready for this session to begin.
Yeah.
In just a minute.
Yes.
And we
Nice to
apologize.
see you again, Jeff.
Good to see you, Victoria. So we
Hi, Shirley.
we just did not,
Hi,
Hi.
Becky.
Hi.
we just did not have time to do a proper test run, et cetera, et cetera. And also another way to do it is to collate all the presentations, but then someone has to sit there and advance them. This way, at least with each speaker uploading, they have the ability to advance the slides as they please. So it's good. Welcome back. We're starting back with this third session on Tropilaelaps species. And just so everyone's on the same page, Tropilaelaps is represented as a parasitic mite that's represented by at least 4 species, perhaps more. And we'll hear from 4 different speakers about it. And yeah, my name is Jeff Pettis. I'm president of Apimondia. And yeah, I'm going to probably forget. So I'm going to thank Fanny and Robert for putting this together. I think it's a very helpful session. And if you don't have this pest already, any pest already in your neighborhood, you can see that these things like hornets and small hive beetles and even Tropilaelaps can spread. So we all have to be aware. I'm going to go ahead and share my screen. Yep. Okay. So can you see that? I assume you can see my screen now.
Yes,
Yep.
we do.
Okay. So what does fire have to do with invasive pest? This is a title I used in another talk, Beekeeping in a Changing World. And the world is changing in a couple of ways. One is climate change. And we've already had some references to that in talking about hornets, where they're reproducing throughout the year in Italy, but not in other areas and stuff, and even small hive beetles. So climate change can affect how these pests and problems move around the globe. But here we're supposed to be talking about the pests themselves, which are Tropilaelaps, hornets, and small hive beetle. So I just put that in there to remind us that climate change is affecting the things that we do in managing honeybees. Tropilaelaps mite. It's a much smaller mite than Varroa, about 1/3 the size of Varroa. It's lightly sclerotized. It does reproduce in brood, so it reproduces very similar to Varroa in the brood. But as far as we know, it does not need adult bees. It does not feed on adult bees, nor does it may be present on adult bees, but it doesn't feed on them. So I like to think of it in this case, it's a faster reproducer than Varroa, and it's also faster movement. So you can think of it maybe as the fast mite. We have no evidence that it feeds on adult bees. And so by not having to spend time in feeding on adult bees, it can move right out of the brood cell into another brood cell and start to feed immediately. So you get faster buildup of Tropilaelaps than you do of Varroa. So a couple of questions. When and how will Tropilaelaps move out of Asia? We've thought for some time that a brood break in temperate areas where it gets cold, that a break in the brood cycle would prevent Tropilaelaps from becoming a problem. But that's in question I would say. And this is what this thing is about. We always felt that because Tropilaelaps needed brood to reproduce and to feed, that where we got a brood break in northern climates, it wouldn't be a problem. But that's coming into question these days. And then last, there's a lot of other questions that we don't know about Tropilaelaps. One of the important ones for beekeepers is, are some of the things we're using on Varroa treatments, are they sufficient to control Tropilaelaps? And there's ongoing work by a number of people around the globe on this issue of control. I will say that formic acid has been one of the major tools, and it is effective, as is things like vaporized amitraz. So there are control measures for Tropilaelaps, but there's still work to be done there. About the winter survival question, can Tropilaelaps survive in the winter without brood? Well, first of all, there's three possibilities for getting through the winter. One is diapause. This mite is the whole group, the family of mites is free living mites, and a lot of them do diapause. We don't know that about Tropilaelaps, but this is still an open question. So the diapause question has not really been explored, but it is plausible that these mites could be going into a diapause in the winter. The second item there, alternate host. This comes from the first definition of Tropilaelaps, which was done by Mercedes Delfinato way back in 1961. And she collected Tropilaelaps from the nest of honeybees in Philippines, and also from rats that were near those nests or in those nests. So she documented that Tropilaelaps was present on the rats. And while that work has never been followed up, there's no reason to doubt it's not true. So it could be that even if a colony goes broodless, that the mites could move off and use other things to reproduce or to feed on. Maybe not reproduce, but feed on. And Delfinato Baker's work certainly points to that. So there should be more work done on alternate hosts within Tropilaelaps. And the last item listed there is brood rearing in winter. We thought that in temperate zones, brood rearing, maybe there'd be a complete brood break. And I was just recently, Chuli Zhang at Andong University hosted myself and others, and we saw brood rearing in colonies in January and February in Korea, which is fairly cold. I also saw the same in February in Canada, where 4 packs of colonies that were under insulation, when those colonies were open, they had active brood rearing in Canada. So this question of a brood break really has to come into question, and that perhaps colonies in northern environments are maintaining brood throughout the winter. And this could be an advantage for Tropilaelaps, a disadvantage for the beekeepers. Just a few pictures from that trip to Korea. On the left, you see there some little black tubes going into the hives. They do some feeding that way with a kind of automatic feeding system, but they also have a system where they can actually heat within the colony, have a heating board and do some heating, which would also stimulate brood rearing. And the other thing on the right there is protein patties. They do a lot of protein feeding in the fall and winter to stimulate brood rearing. So, and then you see a picture in the middle there of just a brood frame from Korea. So again, the break in brood cycle is probably not going to protect us in many parts of the world. How else can Tropilaelaps move or survive? There's been a couple of studies done on, could it survive on bee equipment or bee things like pollen and royal jelly, things like that. So the study that I was involved in, we used a pollen honey mixture. The mites died in 3 days. They died in 3 days on royal jelly or queen candy. And even honey alone, they cannot feed on any of those things listed there. The other study published in Insects, they again, on dry pollen, 3 days, the mites died in 3 days. But look at the dry comb. In dry comb, they live twice as long. So there's something, they were able to scavenge or do something, or maybe it was humidity driven, who knows. But in that study, the mites live twice as long on dry honeybee comb. And then lastly, if they don't have bee equipment, can they survive on adult bees? And there's been several studies done of this. And in general, they tend to die in 4 to 9 days. It's kind of variable. And I think some more work could be done here. But taken together, we have no evidence that they feed on adult bees. And in general, they die within 4 to 5 days on adult bees, and the same on hive products, if you will. How could they be moving around the globe? Well, there's a lot of ways, and Francois Diaz touched on that with trade goods and the like. I'll just talk briefly about package bees. We move package bees around, and the question came up. Project APICM in the US funded some work that I'll be doing on package bees. Can Tropilaelaps survive in package bees? And also, I'm working with the European Union. You'll hear more you'll hear more about that. The Bee Guards program in the European Union, and I'm looking at Tropilaelaps survival, winter survival, and alternate hosts. So there's ongoing work on some of these mechanisms, both how does it move around the globe, and also how can it survive in different environments, and could it have alternate hosts? So actually, that's, I think, the extent of my presentation on Tropilaelaps. You hear a lot more from some of these other colleagues, my other 3 colleagues here in a minute. But I'd be remiss as Apimondia president if I didn't say this whole session that you're hearing is part of education and outreach. And if you want more information, what you really need to do is attend an Apimondia Congress, where we bring beekeepers, scientists, and others together. We have one coming up in 2025 in Denmark and in 2027 in Tanzania. So it's a good forum to share experiences and ideas. So with that, I'll close on that Apimondia plug, but it is a good venue to reach out to others and to hear from scientists and beekeepers. Stop sharing. And so our next speaker in this line is a colleague from here in the US, Jeff Williams. Jeff is a professor at Auburn University. So Jeff, the floor is yours.
All right, thanks, Jeff. Hi, everyone from rainy southern United States right now this morning. And I'm looking forward to going to Apimondia next year, Jeff. So thanks for reminding me about that. Okay. Can you all see my screen here? How does the screen look?
We've got it. It's good.
Okay, perfect. So thanks, Jeff, for that introduction, Tropilaelaps. I'm actually not going to talk too much about Tropilaelaps, but more talk about an opportunity that one of the organizations that I work with could help to prepare for Tropilaelaps. So I'm an executive committee member of an organization called Colossus, and really happy to be joined in this session by Chuy as well as Vicky, who are both also executive committee members of Colossus. So just as a little refresher for those of you that aren't familiar, so we're a nonprofit that's based out of Switzerland, and we currently have over 2,000 members from over 100 countries that participate in our organization. And so we have representatives from academic institutions like universities, government, federal and state levels, scientists, regulators, as well as other nonprofit members. And so all of us are working for one purpose, and that's to promote honeybee health. So that's our overall mission, and we really do try to have a global perspective, although of course it's born out of a cost action, so it really is sort of Eurocentric, but we're slowly trying to expand its reach. And myself being in the US, as well as having Jeff and others in the US really supporting it, really are highlighting how we can expand Colossus's efforts outside of Europe. So we do our efforts through a number of different ways. So we coordinate honeybee monitoring and research. In particular, we help develop standard research methods. So our probably most well-known example of this is the Colossus Bee Book, which is freely accessible via Journal of Apicultural Research. And then we also help disseminate knowledge and provide training by hosting annual conferences, as well as provide opportunities for scholarship for developing scientists and graduate students. So we're organized in a couple different fashions. So we have a 15-person executive committee member that has representatives from 3 different continents. And I think that's the first time ever we've had that. So myself in North America, we've got several in Europe, but we also have several colleagues in Asia, which I think really sets the stage nicely for how Colossus can further contribute towards this Tropilaelaps possible threat. And our members are also categorized into one or more different core projects or task forces. So core projects are sort of our sustained kind of emphasis on bee health. So we do monitoring programs. We have our standardized research methods through the CLOS Bee Book, and then our bridging between research and practice, or research and stakeholders. That's our BRAP group. And then we have a bit more dynamic groups with specific, more narrow foci, for example, like looking at agricultural chemicals, looking at bee nutrition, also looking at viruses. When we look at all of these sort of groups, a lot of them have really close connections to the theme of our event today, like invasive pests. So our monitoring helps to monitor and gain feedback from beekeepers on the effects of some of these introduced parasites and pests. And our bee book actually has several chapters talking about standardized methods for Tropilaelaps, for example, or small hive beetle. And then, as you can see from our task forces, many are geared towards current threats that have come from outside of Europe, such as Vespa or small hive beetle, and of course Varroa for many years. So we do not have a task force geared towards Tropilaelaps, and that's one thing that we're currently working on and discussing. So one of our main activities is to host workshops for each one of these core projects and task forces. And we've been really successful at bringing people together for discussion, which I think is another highlight of CLOS, and also something that's really great about Apimondia, bringing people together to discuss. So we've hosted more than 50 workshops across Europe, and we've had several events in the recent years in Asia, for example. We had one in Korea and an upcoming event in Thailand. And then we've also hosted several meetings in North America, particularly connected to small hive beetle, for example. So we heard from Jamie Ellis. He hosted one CLOS event in Florida. So some of our outputs are not particularly easy to quantify. And again, it's this networking that's so important in modern day science, bringing people together from different parts of the world or different fields to, again, promote honeybee health. But then some of our outputs are can really be nicely measured. For example, the task force for monitoring has been tracking colony losses throughout Europe and other countries for many years, and you can find these publications in Journal of Apicultural Research. And then Varroa, which isn't particularly talked about during our session here, but another introduced parasite to Europe. And there's several great examples of how that Varroa task force, with several people in this session, like Vicky, for example, have participated in these trials that are kind of collective standardized research across continents. And again, this is how CLOS brings people together to provide opportunities for discussion and to come up with these coordinated experiments. So CLOS task forces are ideally created from the bottom up. So a group of CLOS members would submit a request to the executive committee, who would review those based on like certain criteria, like are they aligned to the CLOS mission? Are there clear objectives and outputs? Is there really willingness for a couple leaders in that group to take charge and rally everyone together around discussions and projects? And most importantly, is it science-based? I also want to quote our president, Peter Neumann, who frequently says motivase is the greatest enzyme. And do we have a group of people that are really motivated to make a difference and work towards promoting bee health for whatever kind of topic they're working on? So the biggest question right now that we've been discussing in terms of new task forces is whether or not we're going to create one specific to Varroa or to Tropilaelaps, or are we going to modify our Varroa task force to be a little bit more all-encompassing to ectoparasites and ectoparasitic mites? So that is a current discussion, but it's really, these discussions have really come to the fore, given that we're going to hear in a couple minutes from some of our colleagues about the possible expansion of these mites into more temperate areas, which of course threaten Europe as well as North America and a few other places. So it's really clear right now, like if you want firsthand knowledge about Tropilaelaps, you need to go to where they are. And so that is in Asia or very northern parts of Oceania. So it's really critical that we connect with the stakeholders, like the beekeepers. Here's two examples of beekeepers in northern Thailand that have to face Tropilaelaps every single day of their lives. in the background on that picture on the right is one of my colleagues from Meifa Luang University, Professor Golf. So we really need to connect with the stakeholders, and we need to go there and learn firsthand from their experiences. So again, that's why I think that the idea of this CLOS task force and moving forward more Apimondia special sessions that are bringing together people from different parts and different experiences so that we can benefit from one another, because we can only talk so much by like sitting in North America or sitting in Europe. We need to go there and get firsthand experiences. So one of my colleagues at Chiang Mai University, Dr. Baum, hosted us to do a management trial using US registered products, formic acid and AP Biaxol. And so that was funded by the USDA APHIS group. And so as Jeff kind of alluded, it seems like these brood breaks are super important, but they didn't eliminate the mites completely. So more research is needed, particularly in the framework of kind of like the regulatory aspect and product use in our own countries outside of Asia. Again, to highlight these connections with our Asian counterparts, BAUM also hosted the Apiary Inspectors of America that was funded by a Project APIS-M and North Dakota Department of Ag grant, where we could go there, bring inspectors from the United States to gain firsthand experience. And I know similar experiences are happening throughout the world. For example, colleagues Maggie Gill in the UK are also going to Thailand and Asia to learn these experiences. So I think that we can build from these and kind of work together. And I think that's where an opportunity for COLOS and one of our task forces can really like drive home our knowledge gain and also to develop possible action plans for when and if that mite does reach our shores. So just a quick recap. So COLOS, it's all about communication and networking and being together. So we've really had some success with these task forces, had some nice outputs, and hoping that this is an opportunity for Tropilaelaps. So I'll just say stay tuned for now. And thanks to all of the trusted sponsors that COLOS has had over the years, particularly Ricola and Vita Pharma. So thank you very much.
All right. Thank you, Jeff. Very good. Yeah, I'm kind of encouraged by all the discussions that are going on around, in particular for me, Tropilaelaps and people being aware and trying to be proactive in a sense. So our next speaker is Dr. Chuli Zhang from Andong University. And I can tell you that Chuli is an excellent host. So if you have an opportunity to work with him, Chuli, the floor is yours.
Okay, thank you. Can you see the screen okay?
Yes, it's good.
Yeah, okay, then I will give you a small talk on the first record of genus Tropilaelaps from the Central Asia, and I will also discuss the variation of the genetic and morphological characters. And actually, I had the opportunity to work in the Uzbekistan with the Tashkent State Agricultural University teams, so that I will give you some of our findings. So as you all know, that honeybee has three groups of ectoparasitic mite and tracheal mite, Varroa mite, and Tropilaelaps mite. And in Korea, we have Varroa mite and Tropilaelaps mite. So Tropilaelaps mite in Korea especially came from the southern part of China from 1993. And then we have lived together with them for now about 40 years. And this Tropilaelaps mite has been reclassified by Anders and Morgan in 2007 into 4 species, as Tropilaelaps claria was the beginning, and then Canigerum, Thai, and Mercedesa. And its developmental stage is the same with the other mite groups, and infestation is very typical and close to Varroa mite infestation, but they differ in the wandering stage, and they do not have the phoretic stage. And 2013, Anderson and Robert reclassified as mite living in Philippine area was classified as Calabria, and in all other places, if the body size is smaller than 700 micrometer, it is Tropilaelaps canigerum, and if body size is bigger, but if female Calicera has no apical tooth, it parasite only Apis laboriosa, and the species is Tropilaelaps thai, while the other mite female Calicera having one apical tooth present and parasiting on Apis dorsata and mellifera. These were grouped as Tropilaelaps mercedesa, and we know that Tropilaelaps mercedesa has many different haplotype has been reported parasiting on Apis mellifera. So during the survey of the parasitic mite in European honeybee in Uzbekistan 2022, we found a series of female species of so-called Tropilaelaps mite from the area of Kirgizh near the Tashkent, Uzbekistan. So this is the area we found the mite. And then we brought the mite and then morphologically identified them as Tropilaelaps mercedesa. And this is the new record actually from the Central Asia in Uzbekistan. And this was the first finding of the mite, and then we compared this mite morphology with Korean specimen and also with Nepalese specimen. And A and B and C and D are the different group, and A and B are the mite from the Uzbekistan. So if we look at this degree of sclerotization of the ventral shield, this is quite different. And second, also density of Opisoma gastric seta, the density of the seta are different. And finally, the presence of a small tip of mucro at the near angle of apical tooth are different from the other species. So we found that, okay, this species might have something different. And also we have questioned how this mite came to this area. So this was our basic assumption that maybe they have come from the south or come from the north, because this red part is the so-called current distribution of Tropilaelaps mercedesa, and now we found them in Uzbekistan. So that we had done the genetic variation study with our collection plus with the GenBank database. And we extracted DNA and PCR and sequence, and then we did the phylogenetic relationship analysis and haplotype network analysis. The result is like this. So actually, the Tropilaelaps mite, we can consider there are four groups into two clades. So one big clade and small clade, and very small clade is Sri Lanka Philippine clade. And in the clade 2, there is a Malaysian subclass, Indonesian subclass, Tibetan subclass, and mainland subclass. And most of the mite belong to this mainland subclass. And for example, our Korean population and Thailand Korean population, China population, but here we can find the Uzbekistan population belonged to haplotype H1 group, and they are very close to with the Pakistan populations. Okay, then we look at haplotype network. So where is this Uzbekistan population belong to is here in H1. H1 is shared with Pakistan haplotype, and they are belong to H19, which is the biggest group of these Tropilaelaps haplotypes. So based on this, and we possibly suggest that the invasion pathway of this Uzbekistan Tropilaelaps would come from the sideway from the Pakistan area to this Uzbekistan. And also very recently, we are hearing some story, some news that this Tropilaelaps mite is being reported from the Russia, and also there are some suspicion from Iranian area, so that probably this population on this west side progress is being yeah. So in conclusion, that actually intraspecific genetic divergence of Tropilaelaps mares, this suggests, number one, very close association of the Uzbekistan population to Pakistan population. And number two, there are very clear separation from the Philippines, Sri Lanka clade. So that maybe this population, for example, Philippines, Sri Lanka population, maybe can be distinguished maybe to the subspecies group also. So we need some work on this. And second, the prevalence of the H19 haplotype was the most was the main Asian population group. And also, we found the morphological difference indicate that there are some intraspecific variation in different geographic zones. But important now is that Tropilaelaps mite is expanding its distribution and becoming invasive and requiring collaboratory monitoring, surveillance, or even management research in globally together. So that our finding was very recently published in the Frontier, so you can access. And also this research was partly supported from my side, the National Research Foundation of Korea project and Uzbekistan Beekeeping project and Smart Beekeeping project funded from our funding agency. And very recently, we are beginning to have a new collaboration with Jeff Pettis, Jeff Williams, and also from US, and Panjera Delphine from Europe and Netherlands, and also Bajari Chuton Group from Chiang Mai, Thailand. And we have been keep communicating together, and also we are beginning some field work today this year. So hopefully we can find some better information on this species. And finally, this is some view of photo of what we are doing in Uzbekistan and our lovely but also very destructive mite groups. Thank you.
Thank you, Chuli, very much. Yeah, good presentation. And yes, so the mite is definitely expanding. And we're going to hear a bit more here from Victoria in just a second. So Chuli, if you can stop sharing.
Yes, yes.
Okay. And then our last speaker in this section is Dr. Victoria Sorker from the Volcani Institute in Israel. So Victoria, the floor is yours.
Yeah, I'm just trying to get to my presentation. Just one moment.
Yeah, no problem.
One moment, because it was there before. You know how it is. And now I'm looking for it.
You'll find it. You'll find it. It's okay.
Yeah, of course I will find it. I'm just trying to. Just a minute. I don't know. Just I will.
In the meantime, maybe there are questions in the Q&A section. So maybe, yeah, Chile and you, Jeff, maybe you can answer if you have time. Otherwise, we will collect them at the end. But yeah, maybe some of them, they are very easy to be answered correct, directly.
Just because I see it, but you don't see it, so it's not good. You don't see it, yes?
No, not yet. Not yet. Yeah.
Okay, so let me just share screen, and here it is. Do you see it now?
It's coming up. Yep.
Okay. Now I should do full screen. Okay. So thank you very much for giving me the opportunity to present the work that actually is more work of Anna Brandorf from Rodzinsky Federal Agriculture Research Center in Russia. But I have been collaborating with her on mostly on remote basis. And here I would like to show you what I think. I feel like I more act here as a mouse of this huge part of Russia that doesn't have, even now when they wanted to connect to webinar, they did not succeed. So I don't know what's going on there. But what I wanted to show that actually all these spots that you see brown, that's where the Tropilaelaps was recently found. And you can see, so when you see this spot is, you can decide this is definitely Russia by all political means, but here we are getting in a trouble. If you look on one map, it's in Russia, and another map, it's in Ukraine. For me, it doesn't matter, because here I'm the voice of, I would say, of Kolos, of Apimondia, because what I would like in my talk is to call for attention. And when I started doing this, to spreading this knowledge, what we knew is about these two spots where the mites were. But now we know already that it's in Crimea Peninsula, and we know also that it was found in Kazakhstan, Shymkent. And it was found there because we started talking about it. And also after Anna and I started talking about it, it was found there. So you can understand how significant is actually what you guys in Apimondia are doing. And I see that we have now 197 people in the webinar, and it will be also heard as a recording by many more people. So I think it's very important to see that after all that has been said by Geoff and by Jeff, and of course by Charlie, you understand how fast the mite is spreading. And here you can see that's, you see the connection maybe between Uzbekistan and Kazakhstan, because here where the mite was found now in Kazakhstan, and this is the area when you look where it was found now. And the story actually for this Russian story started in 2021 when Anna started hearing that there were some colonies that were very weak and they are dying, and then she went to see, and what she actually saw is that these typical symptoms in the colonies, when you see that little holes, that may be something else, but you also see these workers with protruding tongue, that means like they are hungry. And then when when the cells were open, you could see how many mites are running out of the cells. And so you can see this situation is quite horrible. And more than 50% of the colonies that were infected in the area of Krasnodar and Rostov, they just died. And you can see the mites were measured, taken out, were measured, and the size was a bit small between Clara and Mercedes, and at that time, it was not yet clear what it is. And so later on, also the study was made to show, that the 50 colonies were monitored over the year period. And you can see in the yellow is the population of the bees, the brood in the colony, and the blue these are the levels of brood infestation with the mites. And you can see that actually in September it was the peak. And but then in February, March, April, the colonies were almost free from the mites. And you can see that actually they were not found in the adults. They were not in the brood, although the brood was present. And this brings us to these questions that Jeff already raised about what happens to the mice, where do they go, what do they do? And then the first question was a very important one, what it was. Now that we have the publication of Shirley, it's probably very clear that it should be Tropilaelaps, Mercedes, but at that time we didn't know what it was. So the samples were collected and sent to Orlando Yanes and Peter Neumann in Bern. Bee Institute, and they made the analysis examining cytochrome oxidase subunit 1 gene, and they found that quite 99, almost 100% identity to Tropilaelaps mercedes. So the question was answered. We know today that it's absolutely clear that it's another case of Tropilaelaps mercedes that migrated further to the west. So the questions that started by Jeff and Pettis and still there, how long can they live in broodless colonies? How do they spread? And regarding the spread, we clearly know, I mean, it can be hypothesized that to Kazakhstan, they came from Uzbekistan, because there is a lot of illegal transportation of packaged bees from Uzbekistan to Kazakhstan annually, because they lose a lot of colonies during hard winter times, and they need a lot of colonies for pollination. So they bring, and it's clear, all these previous talks about how the pests are spreading. In this case, it's quite clear. How exactly they came to Russia, we don't know yet, but maybe by collaboration, maybe with Shirley, we can find out what are exactly the source of those mites in Russia. We saw that, of course, they live with Varroa. Tropilaelaps lives with Varroa very nicely. And I mean, one doesn't harm the other. We are the efficient method of control. I also understood from my colleagues in Russia that formic acid is very good, but of course it requires further studies. What I would like to call for attention about what should we do about this invasion, and that's what I keep saying for now almost a year since I first heard about Tropilaelaps in Russia, that I would like to call for attention in beekeeping community, especially in the neighboring country, and call for monitoring. And this is only the way in which we can prevent the spread. And as already was said by our plenary speaker, prevention is the best. What we can do is the most important thing, because once it's there, there is very little that can be done. With all this said, I would like to thank very much Maria Ivalova, the one that participated in the collections of the materials and monitoring the colonies in Agriculture Research Center in Northeast Kirov, of course, to Orlando Yanes and Peter Neumann from Institute of Bee Health in Bern, Switzerland, for the identification and collaboration on this effort. And thank you all for the attention.
Thank you, Victoria. I think what both of these last two presentations highlight is the fact that Tropilaelaps is on the move, whether it came to Pakistan or whatever. Some of that is due to human movement, but we also still have other ways that you trade goods and stuff. So it's and I agree with you, Victoria, that public awareness, and by public, primarily beekeeper and other people associated with the bee industry, is probably our best and line of defense. So we need to continue to get this word out. We have 1 minute before the next session is supposed to start. So I'm going to kind of stay on time and just say that we will look at the questions and answers, and I've seen some of them, and we will produce a small document that goes along with this whole session to try to bring together some of these ideas, things that were raised in the beginning, and like about the hornets. You know, in some places they die out over winter, and other places they're persisting. Our Tropilaelaps, the fact that, you know, we know it's on the move, and what we can do to raise awareness. And even with small hive beetle, there's things that we still need to understand and spread awareness. So I'm just I'll close this session by thanking our speakers on Tropilaelaps. And it is a pest that apparently is on the move, and we need to be aware. So I'm going to close that out, and I'll turn it over to Robert Klebo, who is one of the co-organizers. And Robert, you can take it for our last session on European projects.
Okay, good day to everybody. I will moderate the fourth session of today's webinar, which will be devoted to European projects. So we have 5 speakers here who will be presenting ongoing European project, the Better Bee, Bee Guards, Be Safe, Bee Honey, Beetle, and Pollinator Hub. First speaker will be Dirk de Graaf, who is the professor at the Ghent University in Belgium. Until 2023, he was a coordinator of the Bee Good project devoted to sustainable and healthy beekeeping, and now he is a coordinator of another EC-funded project called Better Bee, devoted to honeybee resilience. And I would like to ask Professor Dirk de Graaf to start the presentation.
Okay, can you hear me all? My
Yes.
sound is okay. Okay, then
Yep.
the next step is to share my screen. Okay, share. How does that look?
It's visible.
Is it in presentation mode?
Yes, okay.
Okay, so let's start. I have only 7 minutes. Future actions under Better Bee. This is, let's say, a presentation that is a bit different from all previous ones, because it is about a project that has a lot of things to do, but little on invasive species. I will try to keep the balance between telling what the project is about and telling what we are doing on invasive species. So Better Bee stands for Improving Bees' Resilience to Stressors by Restoring Harmony and Balance. It is funded by the European Commission. We have 16 partners plus 2 associated partners coming from 14 countries, multidisciplinary team, and we started the 1st June 2023. When I have to select one sentence of our proposal that says most of where we stand for, then it's this sentence: the key to resilient beekeeping is to harness the power of nature to restore harmony and balance inside the honeybee colony and between the colony and the environment. So this is a bit the theme where we are working around. Now, there were 2 projects rewarded in that call, one on abiotic stressors and another on biotic stressors. Ours was on the abiotic stressors. Here on the right-hand side, you see the different work packages. They are focusing on landscape carrying capacity, exposure to chemicals, climate warming, specific local context, heat and nutritional stress, climate warming, plus, and then here you have invasive species, you see. So there is a lot of other things. In fact, this is more, this project is more on abiotic stressors. So, okay, we look at what happens in nature, more or less. and try to answer some of the questions related to, for instance, colony density, resilience to chemicals, resilience to climate and heat stress, local adaptation by Darwinian selection, immune resilience, hive construction, and beekeeping practices. So what I have done, I have made just a half a slide for each work package so that we can rapidly go over different work packages. And I have just given the questions, the research questions that we asked ourselves. So in work package 1, pollinator ecology, the question was, can we predict the landscape pollinator carrying capacity and the competition with wild pollinators? So we believe we can. And then based on that, we will develop a tool for landscape level management of honeybee density. Then the second work package is on resilience to chemicals. And here the question is, can ecosystem complexity enhance the resilience to chemicals? And then another was that we will develop a tool for insecticide target site mutations. So the idea is to look at all the mutations you have in these target sites of these insecticide and see whether some of them might give bees, let's say, some more resilience as a second question in this work package. Work package 3 is resilience to climate and heat stress. Can we predict the effect of climate change on beekeeping based on genetics? So, and then another are the genetic markers associated with heat stress? Can we design novel hive types based on in-hive thermoregulation? And what is the impact of heat stress on key biological mechanisms of the honeybees and of the Varroa mites? A fourth work package is then on local adaptation by Darwinian selection. And here the question is, what are the characteristics of Darwinian colonies? So we will give a natural selection a new chance, and we will look at the genetics of these colonies when they evolve, and we will also look at, let's say, parameters from hive monitoring systems. And then another question here is, what is the impact of mobility of beekeeping sector? And we look at colonies that are locally adapted and changing at another location and see how they behave, whether they still are well adapted or not. Another one, the fifth one is on immune resilience. And here we will tackle something that is at present under studied in the field of immunology. Yeah, I mean, the hemocytes, we do have some typology, but we believe that typology based on surface determinants, as it is in higher organisms, might help us to have a more in-depth study of the cellular immune response. And then we will see what is the impact of heat and nutritional stress on cellular and humoral immune potential of the honeybees, but then with the cellular immunity studied more in depth. Okay, now we are here at the sixth work package, Future of Beekeeping Under Global Change Pressure. And here the question comes related to the invasive species. So can the optimization of hive and apiary as well as beekeeping practices mitigate sudden disruptive events, permanent climatic stressors, and invasive species? And which regions in Europe are at risk for the spread of invasive species, and what can we do? So these are the questions. What are the tasks? What is in fact our approach? So the first task is that we about hive construction, we will make an illustrated booklet with practical tools and methods. And then here in yellow are the ones that are really with respect to the invasive species. So we have a risk assessment study that we will perform, also a contingency plan targeting the invasive species, and we will develop a PCR for rapid confirmation of Tropilaelaps species. In the third task of this work package, we will have an online tool for selecting the IPM strategy for invasive species. And we will, for Vespa velutini, we will perform a citizen science study with traps, and for the whole small hive beetle, we'll perform field trials. Now, problem is a bit that most of these tasks are not started yet, or only just started. Most of them are planned. The work package leader is Giovanni Formaggio. He was already chairman here in one of the sessions, and he will give another talk after me. We had let's say a chat to explain what exactly was planned. But of course, when I look at the content of other talks here, let's say this is let's say not well developed yet, but please keep in mind that we are just starting. So what I did is a question breakdown. So the risk assessment study, here we question which parameters determine the establishment and spread of an invasive species. How are these parameters changing across Europe? What is the estimated risk of the potential invasive species? And then creating a kind of heat maps showing the level of risk across Europe. For the contingency plan, we ask, okay, which actors should be involved? Then a step-by-step plan of the measures to be taken, who and how to alert the finding of a suspicious specimen, who and how to confirm the diagnosis, what to do when with the affected apiary, control or eradication strategy, how to stop, minimize the spread of the invasive species, how to monitor the neighboring regions. Approval of the plan by the responsible authorities, communication to the beekeeping sector. I understand there is a lot more to put in a contingency plan, but please, this is just a few lines to give an idea in which direction we go. For the integrated pest management, there will be some pilot studies. The first one are citizen science studies for Vespa velutina with for the effectiveness and selectiveness of different traps. So we have the velutina trap from B Vital, we have harps, electric harps, and we have also the Vespa catch from Veto Pharma that we will test it in a small setup. For the on-field trial with Aethina tubida in Calabria in Italy, we will work with two mechanical traps, the Beetle jail and the Beetle blaster, and we will do that alone or in association with the mobile divider that you see here on the left picture. The online tool to select the IPM strategy for invasive species. Here we question which good beekeeping practices help to control the invasive species, under which environmental circumstances can they be adopted, which control measures are available to us, and in which business model do they fit, how are they influenced by the environmental conditions, and then which IPM strategy gives satisfying results for a given region and a given business model. And so the tool will be that it's a website application that the beekeeper can give input about his business model, about the region where he works, and then we give some suggested IPM strategies, sometimes just a single or multiple with the pros and the cons. So this is more or less what we plan to do. So these are our funding agencies, and this is a picture of one of our consortium meeting. Thank you for your attention.
Thank you very much for the short introduction and goals of your project. And because we need to keep the time schedule, we'll go directly to the next speaker, who is Professor Gilles Butch. Is an applied researcher in honeybee health from Newcastle University, with expertise in pathology, pest control, diagnostics, and surveillance. Gilles currently works in the Modeling, Evidence, and Policy Research Group at the Newcastle University and sits on the steering committee for Bee Guards, where he is responsible for the delivery of working package 6, which has a focus on invasive pests. So, dear Professor, floor is yours.
Brilliant. Thank you. Thanks for the introduction, and thanks for giving us the opportunity to talk about our project Bee Guards. And Bee Guards, Dirk is a king of his project, and we have our queen. We have Cecilia Costa as our lead on this project. We have 27 partners, not just from Europe, but from beyond Europe shores as well. So it's quite a large collaborative effort that we have put together as part of this project. And the project itself is really interested in trying to improve our understanding of resilience. And we can see here one of these wonderful plots that you get in these EU projects where you try to bring everything together. And really the thing I wanted to show you on here is how we're trying to tackle these different levels of resilience: individual bees, colonies, beekeepers, agro-ecosystem, and society. And a lot of what we've been talking about today when it comes to raising awareness of invasive species is around that sort of raising that sort of societal awareness. I wanted to highlight that we're not a closed shop. We've got elements which we share really quite a lot. We've got our website, we've got Work Package 9, which is very outwardly facing, runs the website, and also we have this multi-actor forum, which would allow anybody interested to join, and then we will have meetings whereby we help to co-design certain aspects of the experiments that run across all of these different work packages. I felt 7 minutes wasn't enough to go through each of these individually, so I'm going to concentrate on the one that I am responsible for and lead, and that's work package 6 here, parasites and pathogens, because therein lies our work on invasive pest species. This particular work package, around a dozen or so people working across lots of different partners. The partners at the top of your screen here, actually, you recognize some of the names, Fanny and Jeff are on there too. They're leading the different tasks within this work package, supported by individuals across the bottom. So you can see all of our efforts within all of our tasks are really deeply collaborative, this project. Let's go into a bit more detail about what we're trying to achieve within this work package 6 on parasites and pathogens. We actually also targeted abiotic drivers. So we have this work package which is interested in biotic threats, but it's also thinking about those biotic threats by considering the abiotic drivers, which are beekeeping management practices, M, climate, both now and in the future, C, and nutrition, which is N in the next figures. And we can break down the tasks into different areas. And I don't want to spend too much time on these because I want to get through to the invasive species section. But we're going to be looking at how climate and management practices influence both the honeybee colony and the Varroa colony together. We're going to really try to better understand how the climate, both now and in the future, might encourage certain diseases to emerge across different places in Europe as a result of those weather patterns. But also we're trying to develop some management methods to improve breeding to actually combat some of these diseases that we think might emerge in the future. Now, when it comes to this part, it's another area that you could get involved in. If you have data sets which are spatially explicit, temporally explicit, so they do space and time, and they have disease or pathogen at certain locations, then if you wanted to share those with us, then we could certainly model the sort of disease threats in your area today and into the future. So get in touch if you have those sorts of data sets. The area that I wanted to concentrate on is very much about these invasive pests, and the two that we're going to be working on in this project specifically are Tropilaelaps mites that we've heard an awful lot about already, and small hive beetle as well. So let's have a little bit more of a dive into task 6.4, which is to predict the future spread of invasive pests and developing protocols for their mitigation. You'll see that Fanny and Jeff actually lead this particular task with support from ourselves and also Yanis as well. So what are we going to be doing? Well, first of all, we're going to be trying to model future invasive pest threats, which is similar in a way, actually, to something that Dirk just touched upon. Jeff's already mentioned that there are certain weaknesses in the Tropilaelaps life cycle, which might mean it has to rely on brood breaks or diapause or alternate hosts, and we're not sure what lies therein, but we've got experiments planned to try to understand where those weaknesses lie. But also small hive beetle, we didn't really mention that it's quite temperature sensitive. It doesn't like to survive particularly well at temperatures below 10 degrees. And also it doesn't reproduce particularly well or pupate particularly well in very dry soil. So there are elements to the environment which will drive both the weaknesses in the life cycles for Tropilaelaps and small hive beetle. We've talked about this a lot already through the different sessions today. It's crucial that we understand where the current range of these organisms are, these invasive pests. Tropilaelaps in particular is popping up in places we weren't expecting, whether that's actually recent spread or whether that's actually a recent increase in awareness of these particular pests, I'm not sure, but we need a better understanding of that through this project in order to model. We also, if brood breaks are important for Tropilaelaps, then we need to understand a little bit more about this brood cessation, and Jeff's already touched upon that when he's been to Canada and to Korea. What we're going to do with those data, we're going to use climate and landscape features from the current range to map across Europe to see where it might go both today and using climate predictions, the future. We're also going to be developing protocols for mitigation. These surveillance protocols, we've recently submitted a paper, so that's headed up by Maggie Gill. We heard that she and her research team have been over to Thailand recently to look at these different methods of surveillance. We have to, if we're going to recommend something, we have to make sure it works. I can imagine, I don't know how many of you have actually seen Tropilaelaps moving around, but I think it's fascinating how quickly they move, and you have to sort of see that and share that with people to help them to identify whereabouts in the world these pests have reached. So we're going to look at those surveillance protocols. We're going to commission an international workshop of experts and practitioners. We want to try within that particular exercise to get together the best practices for surveillance, for monitoring, and for the management of these organisms. And then we want to summarize and distribute that across the EU and beyond. So actually we have lots of common goals across these sorts of projects, across Colos, across Apimondia, and we're looking forward to, within Bee Guards, helping to spread the word about these invasive pests and help to control them in the future. Thank you. I think that's my 7 minutes.
Okay, thank you very much. And we will go directly to the third speaker, which will be Ivana Plug-Geiger. She is a professor at the Department of for Biology and Pathology of Fish and Bees at the Veterinary Faculty University of Zagreb in Croatia. She is a head of the National Reference Laboratory for honeybee diseases, and today she will speak about the cost action Bee Safe Bee Honey.
So hello to everybody. Do you hear me?
Yes.
Yes, okay. So you have the slides on it. Okay. So firstly, I would like to greet you all warmly from the Faculty of Veterinary Medicine, University in Zagreb. And also thanks to Fanny to share with me this link, because I didn't get this panelist one. So thank you, Fanny. Here today I have the task as a leader of the working group of the new cost action project. It is called the Beekeeping Products Valorization and Biomonitoring of the Safety of the Bees and the Honey. So I am leading this working group, which is in regarding with the diseases, pests, and parasites. It is titled Evaluation of the Prevalent Disease and Biotic Stressors that Threat the Honeybee Colonies, the Endemic and Possible Important Threats. As I'm a veterinarian, so I really like to stress always the importance of the public health. And from the title of this project is visible that we have a really nice link between the determining the quality and the safety of the food produced by the honeybee colonies. And of course, the management with the honeybee colonies, the different beekeeping practices, and also different biosecurity measures which are implemented in everyday beekeepers' work.
Also, I have to say that we have the 6 work packages, and most of them are related with the determination of different kind of residues of the different xenobiotics from the environment, and of course, this one which came from the regular management with the honeybee colonies. And because we really need to control a different kind of parasites, pests, and now the invasive species which are coming in the area of the Europe, I really want to say that we must find the solutions and must make some recommendations for the beekeepers in the approach of One Health approach or One Health manner, how to do to, in the same time, protect the health of the honeybee colonies, but also the environment and also the humans, because they are really the consumers of these products which are produced by the honeybee colonies. So the main objectives of this working group is to check the effectiveness of the parasites, pest, and now the invasive species control, and in its implementation into the integrated pest management frameworks. Also, the full comprehensive assessments of the diseases, biotic stresses, as well as the new control strategies, the new practices, which will be incorporated in the new geographical informational system platform. And of course, the assessment of possible future threats which are related with this international transport trade in the area of the Europe. So the main tasks of this working group is first the mapping of the diseases, the mapping of the presence and spreading of the different invasive species in this context, but also the biotic stressors in the area of the Europe, and of course the assessment of these possible crossover threats. Then the identification and characterization of subsequent implemented prevention and control strategies on the national and international level, also including the novel control agents and novel control tools or techniques. Then the evaluation of the novel real-time sensors, which can be used for the parasites or maybe also these hornets and mites and other invasive species detection, and assessment of the challenging in these parasites, pests, or invasive species control, of course, in the different level, in the laboratory diagnostic, in the research part, in the regulatory framework, and of course, in the market. So we just start the project in the beginning of September last year. So we currently designing all the activities, and we start just a few activities, and most of them are pretty as a plan. So what we want to do as a group is the identification and evaluation of already existing on-field and lab methods for the early pathogen and invasive species detection. Of course, the methods for infestation levels and their evaluation. And here we want to improve currently published papers with maybe including the data which are published in some local journals, and maybe to include some gray literatures like dissertations and everything, because there are lots of new informations which are not really published in the scientific articles. Also, we want to stress the role of the veterinary medicines and the practitioners in the beekeeping sector by mapping some kind of organization which are really active in that sector in different countries. And also we want to include the possibility to share the knowledge where it's possible to get education in the, for example, veterinary faculties. Then we will check or we will try to be active in the searching with the results and reviewing, summarizing the results about the using of veterinary medicines and pesticides in beekeeping in regard of their distribution, purge, traceability, registration. We will try to collect the official data which are linked to the sold and used medicines in this beekeeping sector, and of course through the monitoring of the hive products, possible detection of the residues like acaricides, pesticides, and other environmental and management contaminations. Also, we would like to collect the data regarding the management practices which are involved in the prevention, control, and eradication measures of the different invasive species, parasites, and pests as notifiable diseases, causative agents. And of course, we as a cost action, we don't have much funding for research, but we would like to make a nice networking of a different beekeeping sector stakeholders, which are included in different honeybee diseases, pest and invasive species manner. And of course, in this part, we would like to do some, make one atlas with nice parameters of morphological identification parameters that can be used in the citizens and public, in the public, in the citizens. Then, of course, some communication channels, maybe international workshops when we would like to make some connections with the very experienced people or professionals from different kind of parts of the world, of course, because most of these invasive species are not yet present in all countries of the European Union. And for example, we would like to do some interviews with the different stakeholders and sharing these knowledge, skills, and their experiences regarding all this chain of from recognizing of the pests to their control or eradication. And we will try to disseminate them through the different social media, articles, reviews, and so on. So the next one, so here I just put one proposal because of the possible published knowledge till today about the Tropilaelaps mites. So we have one proposal which we will, let's say, put some special impacts to get to the techniques based on the brood disruption, then the use of the queen caging techniques, and of course to stimulate to do some to develop some techniques with the broodless colonies during the active season, which can be implemented during the active season and production of the colonies. So the first possibility for or opportunity to make some discussion about these topics as well will be very soon, because we will have the first international conference, which will be held 28 to 29 May 2024 in the Larissa in Greece. So you are all welcome to come to this conference. And of course, if you are in goodwill, you are always welcome to become the member of this nice new cost action. For now, we have included the 52 countries with in total 285 members, and from that number, we have 170 members of this group regarding the pests and diseases. So thank you very much. Thank you for your attention. And my message always is keep the bees together. Thank you.
Thank you, dear professor. And the next speaker will be Giovanni Formato. Many of you know him. He's a veterinarian expert on bee diseases and management. He's the head of apiculture laboratory with Franco Mutinelli. Giovanni is in charge of the FAO Reference Center for Apiculture, Health and Biosecurity. Moreover, Giovanni is head of the Center for Beekeeping Management Practices, and from September 2022, he is a coordinator of the project BeeTenet, the first platform for EU beekeepers on best beekeeping practices for sustainable beekeeping. So we are looking forward to hear the news from this project.
Thank you very much, Robert. Can you see my screen?
Yes, perfect.
Okay, very good. So what about the activities on invasive species under BDNet thematic network? So first of all, I have to say that this BDNet is not a research project, but is a thematic network project. This means that it is aimed to discuss between beekeepers, advisors, the research sector, and even other stakeholders, the beekeeping practices and innovations. This is to define and to validate at the national level the best beekeeping practices. So it's not something that involves the research activities, but it is something that involves the how to do properly things. The output of this BDNet thematic network is the first platform for European beekeeping, and it is the setup of best practices with a multi-actor approach. This means through the interface of beekeepers, researchers, and all other professions that are involved in the beekeeping sector. Another important thing is that the bottom-up methodology is fundamental in BDNet. So when we want to define and describe practices, first of all, we ask beekeepers which practices they consider most relevant for them to define. The thematic network is a consortium of several entities that includes research organizations, universities, international national beekeepers associations, centers for advisors training, centers for social sciences and humanities, and agencies on communication and dissemination. This is the basis of the multi-actor approach. As you can see, we have 18 beneficiaries, and together with the beneficiaries, we have again collaborating partners that could be beekeeping associations. As you can see here, the list, and we have research institutions. So as you can see, the partnership is a mixed reality between people that go every day inside of the apiary and the people that every day make research and work for the beekeeping sector in other ways. So, which are the goals? We already started to say some of them. First of all, with a bottom-up approach to identify the most important practices in Europe. Then to develop these practices through the support of beekeepers, advisors, and other people that is involved in beekeeping, tailoring the practices at the reality of each country. So we don't have to think that we have the same best practice that is done in each country, but we have different realities of these best practices, because practices may change according to the differences in the beekeeping equipment, in the climatic conditions, in the kind of bees that are there, etc. And of course, once that the best practices have been identified, a goal of the project is to disseminate and share knowledge on the validated practices to beekeepers, advisors, and stakeholders. At the end, the final goal is to have a more sustainable, resilient, and competitive beekeeping sector. So where is the place in which beekeepers, advisors can find each other and exchange about practices? We have 13 national BDNet centers in Europe, where these can happen both at the theoretical level and at the apiary level. Moreover, we have 3 international BDNet centers where beekeepers and advisors and other stakeholders may find each other and share about practices, about experiences on how to properly manage bees in Europe. We have a website, and in the website you can register and you can access to the discussion on the different practices. And this is in the platform that is called Exchange platform to discuss together practices. And we have another platform that is called Repository, where it is possible to find the already defined practices. And here it will be possible to take practices as text, as images, as videos that could be used for training of beekeepers in each country. So we have best beekeeping practices that already have been defined, and we have still practices that will define along the project. The project is 4 years long. So far, we ended recently the first year of the project. So we already have some practices defined, and we still have to finish to describe and exchange other practices. Of course, among the practices, we have even biosecurity measures that are those measures that are taken to prevent or to control these honeybee diseases. And among these, we have the involvement, of course, of Varroa and, of course, of small hive beetle. And those are topics that will be discussed more ahead in the context of our project. I hope I was enough clear, and I hope you will be able to visit our website and to support our exchanging activities or provide comments to improve our thematic network. Thank you very much for your kind attention.
Thank you, Giovanni, for interesting speech. And the next and last speaker in this section is Michael Rubinik, who is the plant scientist currently based in Austria. He runs a professional beekeeping operation and a sole proprietorship in the field of the information and communication technology, which was involved in the production of various beekeeping-related software application. He has been working for the EU beekeeping industry for the last 15 years, and we are happy to have him here. So, Michael, start your presentation.
Thank you, Robert, and good evening to everyone. So, you might have noticed a new data hub has recently been launched for sharing pollinator-related data, which is the EU Pollinator Hub. It was commissioned by the European Food Safety Authority and developed by a consortium led by BeLife. This free open source web application allows sharing of standardized data across language barriers. It includes a QMS that should guarantee a high quality of the shared data, and it includes many other features that will hopefully facilitate data precision and management. So why do we need the Pollinator Hub? Well, I think we all agree on the fact that the protection of pollinators requires a holistic approach. It must be as diverse as the multitude of factors that threaten them, and collecting data from different sources, stakeholders, and regions, linking this data, analyzing it, and visualizing it, I believe, is a very important basis for decision-making processes. It will certainly promote a better collaboration between stakeholders in the bee industry. So what does the Pollinator Hub offer? Well, first of all, it provides the necessary technology for collecting and transferring data from a variety of sources to the hub in a standardized way. This means wherever and in whatever format data is available, we provide, or at least we try to find an adequate solution to integrate this data into the hub in order to make it findable, accessible, interoperable, and reusable. In the second step, we'll then provide the technology that allows you to visualize this data. You can easily find the EU Pollinator Hub at pollinatorhub.eu, as shown on this slide, and through the QR codes that are shown on the following slides as well, provided that you succeed to grab your smartphone quickly enough. As you know, there are plenty of initiatives in Europe that aim to monitor invasive species. Some of them we've seen today. And of species that are potential or actual threats to honeybees, but not only honeybees, to other pollinators as well. Fortunately, these initiatives are usually restricted to the regional or national level, depending on the legal situation in the member states or in the various countries, and obviously on language barriers, which in the European Union is a common problem. And that obviously hinders the exchange of data and information. The problem is invasive species don't care about human-made borders. So in order to efficiently cope with these multiple threats, it's necessary to exchange data across regions. And this is where the EU Pollinator Hub may fulfill a crucial role. I am referring to data that is available on different platforms, as you can see here, on hard drives, on publications, and God knows wherever else. In fact, in the case of Vespa velutina, as you can see on this slide, there are plenty of web resources that contain relevant data and information. Basically, we have the situation that too many people are currently doing excellent work, but there is no systematic method to connect this data and this information, which eventually might allow an efficient control of these species. Now imagine a world where this data became integrated into one single place, which makes it easy to share your data with others that are affected or threatened by this invasive species, and which guarantees both traceability and privacy. Well, the EU Pollinator Hub has been designed for exactly this purpose. Again, the software is free and it's open source. Well, I hope that this brief presentation was a little inspiration for you. If you have any question, please contact us or follow us at the platforms that are on the bottom of this slide. And thank you for your attention.
Thank you too, Michael. And yes, we are at the end of the session 4 about the European projects. And yeah, it is a time to go to the remarks and general discussions, and maybe making the photos as the point announced
Thank
already.
you, Robert. Thank you, Robert. Well, if there are specific questions to the projects, maybe people can ask now, and then we go to the questions that they have not been answered in the Q&A section. Could we stop the sharing first? Right, so good. We can all see each other, I hope, I suppose. Yeah, before we go to the last session, I'm kindly asking all panelists to open their cameras if they wish. And I will try, and others, maybe you can do the same. Let me see how I can do the gallery. Yeah, because, well, we should have one photo. We should have done this before. I forgot about it completely, just came to my mind now. But anyway, let's do it now. If somebody doesn't want, okay. So I will try with 1, 2, and 3 to get a photo. Yeah, smile, please. Get another one. Okay, good. Thank you so much. So are there any specific questions to the last session, to the people that they presented the projects? Something to clarify, maybe an issue before we go to the general Q&A session and remarks from them? Because we might have questions within the panel, or they could be questions in the Q&A section, which there was one about the better bee. Dirk, would you like to see it, please? And if there is something that you can answer now, that's fine, or you can answer online or type an answer, or feel free to tell us what you think.
Well, I'm going through the questions and answers.
Is the last one, by Chris Carstens. Because it's more related to the better bee than the
Well,
general.
the answer here is that we do have also a multi-actor forum, so we are always seeking interaction with the key beekeepers, and so there was quite recently, let's say, a workshop on hive construction and the materials and the place where you put your hive and how that can have an influence on the microclimate of the hive. So here that person asks for whether he can get more information about this. So I would say just contact us via our website and become part of the multi-actor forum, so you will be continuously informed about the progress that we made, and we will have an interaction with you in future activities. So this is the way to go, I think. Yeah, hope I answered that question.
Okay, thank you so much. So I would like to call Francois. Francois will lead this last session.
Fanny, Gilles has a question. I think Gilles would like to. Yeah,
sorry
Gilles.
about that.
Yeah, I just had a question for Dirk actually while he was up, and I noticed, that that when you went through what your project's trying to address, and I went through what our project's trying to address, there's a few areas of potential synergy around immunity, pollinator survey, and also I think around future threats. And I didn't know whether or not there'd been some sort of higher level conversation between the groups to see if there are areas we might collaborate. I mean, in some areas, like for example, the modeling future threats, I think it's actually quite healthy to have two groups both working at it independently, because then we have our own answers with our own data and our own methods. And if we have the same answer as a result of that, it becomes more powerful. But in other areas like pollinator survey, maybe there's a way to think about how we might collaborate. So it was just a question around that, really.
Well, I think we've taken already a few steps in that direction. The first one is that Robert Broodschneider, he will publish in the journal Bee World, let's say 2 articles in the same issue, one on bee guards, the other on better bees, so that, let's say, we present our project to the larger public via that journal. Another one is an initiative that was taken last week when we were in our consortium meeting of the Insignia project, where the idea raised that during the Apimondia conference in Denmark in 2025, that we might have a joint initiative, a kind of symposium of these projects, and that we then take the opportunity to show each other what we are doing, and maybe to have some kind of workshops or trainings or activities there to create that communication and collaboration between the different projects. I am very happy with the initiative that Apimondia has taken here. It opens my eyes of the different, let's say, activities that are already set up in the and projects that are running, and in fact we are not standing alone. There is so much out there, and thank you, Apimondia, for giving us learning us that. I think this is my most important lesson from this webinar. Thank you.
Thanks.
Okay, then Francois.
Yes. So we have maybe 10 minutes now for this question.
No, we
answer.
have more than 20 minutes or something. I mean,
17
we are well on
minutes.
time.
17 minutes, yeah.
17, okay. 17.
Okay. So I think we have a first question, which was what trap density is required and in a trap per kilometer carré. And I think it was Alain Gulnik, I think, proposed to reply to this question. So Alain, the floor is yours.
Yes, sorry. In fact, all this data should be disclosed by the intermediate steering committee, I mean the regional steering committee. There are no common rules about that. It depends on the infestation, so there is absolutely no clear rules about that. And this is the same thing about destroying the nest at the end of the year. There are no specific rules. It depends on the latitude and on the weather as well. So there are a lot of let's say location dependent decision to make. There is no definite answer. That's my point.
Okay, thank you. And so we have also another question, and it was, I think it's for you, Jeff. It's a thanks, Jeff. I read a study recently from Thailand indicating that there was a small percentage of Tropilaelaps that survive theoretically for a short period of time on adult bees. Anything to add on this?
So yeah, the study on Tropilaelaps bites on adult bees and survival, it is quite a long range. Most of them die in 4 to 6 days. But there was a study once, I think, by de Guzman in the US. She had them surviving up to 9 days. One thing that could be affecting that is humidity, perhaps. But in general, we still don't see evidence that they actually feed on adult bees. So that, I think some more work can be done. But at this point, we have survival on dry comb up to 6 days. We have on adult bees, perhaps up to 9 days, but most mites dying within 3 to 4 days. So I think it's still a bit of an open question, but in general, they need brood to reproduce. So yeah, still, that's about all I can say. Thank you.
Thank you. We had also a general question, and so this is open for all the panelists. It was how probably is that these mites, and I think it was for Tropilaelaps, reach the Netherlands, for example. Are all these infestations due to the fast climate changing, or is it also because we as beekeepers too often and too much intervene with managing our bees? Thank you in advance for your answer. So it's open. So do we have someone wanted to reply?
I can address it. Yeah. I'm ready to address it.
Okay.
I think I mean, it's nice to find that someone else is responsible. And I think most cases we are responsible for the problems in these particular cases. But definitely the climate changes help it spread, I think, because if there was more brood breaks and now there are less, so definitely it helps. But in long ranges spread, like from, let's say, from Korea up to Russia, I think it in the same latitude, I think it's not the climate changes. I think this is mostly people. I wonder if others agree with me or not.
I would agree, Victoria, that a lot of things, especially with Tropilaelaps, is human movement of colonies. But as we see from hornets coming into France, that was trade goods. So there's other pests that do move with trade goods. And so it's not directly responsible. Beekeeper activity is not directly responsible for it. But I think with Tropilaelaps, at the moment, there's two main ways. Beekeepers moving things around, but the other is, and I think the question came from New Zealand, watch those ports because container ships do have swarms on them, and those swarms can have mites. So swarms readily move onto containers, and those loaded onto ships, and then they move between ports. So we need to be aware.
But it's still human doing it. It's not the climate changes. That's what I mean.
That's true.
It's not that I accuse beekeepers particularly. I'm saying it's us humans.
Very true. Yeah.
Yeah, I will add that yes, I think it's totally humans, and it's also through the trade, the international trade, that of bee products and of bees, and so I will recommend, of course, to avoid as much as possible this international trade of bees, live bees, but also bee products, because sometimes you have the same atom. And so it's better to try to avoid this kind of big international trade, because it's a source of introduction of invasive alien species, and so we need to be careful on this. And after I didn't see other question, but maybe Fanny, you see other one.
Well, yes. Well, there is a question that says that how possible is that the mites can go to the Netherlands, for example? How quickly do we think that they can move from one part of, one side of Europe to the other side of Europe, which is really, I don't know. I don't know if somebody can really answer this question.
I'll make a statement. I think it's from Chuli's and Victoria's both finding the mite in Kazakhstan or Uzbekistan, and there's reports from Iran that it is literally knocking on the door of Eastern Europe, but Eastern Europe is now even more so well connected to Western Europe. So it's incumbent upon all of us just to be aware and to raise awareness within our own beekeeping communities, because we are the best line of defense. Beekeepers are the best line of defense, as well as some public monitoring or monitoring at ports and things like that for introductions of swarms. But yeah, the Netherlands, I think the port of Rotterdam is the biggest port in Europe, as I recall. So maybe the Netherlands is the most likely place. I mean, that's just a rash statement, but it is true. I think I heard a report that Rotterdam is the largest port in Europe. So, of course, there's increased shipping and there's increased risk.
Okay.
I see. So other question. It is possible to kill all hornets in the nest from a distance. I think it was for Vespa. It's for hornets, Vespa velutina, Vespa orientalis, and Michael Rubinik. I think you propose to answer this question. So, Michael, the floor is yours.
Which one? The one from?
It was from Irakli Karshava, and it is possible to kill all hornets in the nest from distance.
Well, I'm the one with the least experience in Vespa velutina probably here, so I can't possibly answer this question. Sorry.
Okay.
You might ask someone in Italy or in France.
Maybe Laura?
I think it is not a question, but the person asked if he can share the methods with us.
Yeah.
Am I right?
Well, something like that I also understood, because
I think the same, Laura. I think I read and I thought that it was this.
It was not a question.
Yes.
But well, anyway, if I may add something, it's technically possible. I mean, there are some paintball experiments, but it's not safe for the environment, as there is no treatment of the nest afterward. So it stays in place, and the birds are going to eat the larvae, and so it's dangerous for the environment. It's like using neonicotinoids. It's the same way of harm the environment. So no, I disagree with the fact that we can do that, even if it's technically possible.
Okay.
Just a new one appeared now that says yellow-legged hornet. Does it make sense to install alive traps in springtime to find queens? If yes, what distance is recommended? Anybody?
Maybe say again, because I didn't catch the question.
I'm not sure if there is difference with the previous one. Does it make sense to install alive traps in springtime to find queens? I'm not sure what it means, alive traps.
No, I'm not sure either. So, yes, trapping queens in spring. Yes, it's well, something that it is recommended by, at least in France, for sure. As I try to explain, but that's it.
Okay. Probably you also saw something that Pega from Iran with the name Ali Reza wrote in the Q&A section for the monitoring of the Tropilaelaps in Iran, and the difficulties there, because they think that it is Tropilaelaps, but it seems that they are not absolutely sure yet, and for how long now they have problems. Yeah, Pega, if you can still hear us, come in contact with the people that they are, working on the subject, and they will be able to help you more, because we had a lot of discussions during Apimondia Congress in Chile with Pega. And thank you for being with us. All right, then. Thank you all. Maybe you will allow me to just mention a few things that I think they are really very important from what we hear today. To my opinion, if we're talking about the Vespa and the small hive beetles, the trapping is really recommended with the different types of traps. And maybe we could avoid the chemical uses to poison the nests. If we want to go to a more bee-friendly and environmental friendly methods, we still need to learn a lot about the tropy in order to see and be able to say if we can have common approaches for Tropilaelaps and Varroa, although they have many in common, but they have so many differences as well. There are guidelines for the invasive alien species from WAH. Maybe we should all go through these documents and see what are these recommendations, may be very helpful. And I don't know, maybe then together with Apimondia, we can make them more publicly available, to disseminate them more to our people. I put a few things down, but not in order, so excuse me for this. It seems that trade of products, trade of bees, trade of packages, trade of whatever, even the soil that it was not mentioned, I think it is very important and can transfer from diseases, whatever, pests and everything. So we have to be really very careful on this. Then if I go to the last session with the research projects, I was really amazed to see how many different approaches there are there, from how all these 4 or 5 now projects they are running in parallel. So we are doing quite a lot of work, at least in Europe, work that could be good example for other continents. And for example, from contingency plans and from the combination of the management, nutrition, and climate in the other project, the networking that some of the projects they are giving us, the good management practices that we try to collect and also to train the beekeepers, to the systematic methods to collect the data and data sharing. All these are really very good. I hope that they will give us even more answers later on. So before I give the word to Jeff to finish, allow me to share my screen because I would like you to say something. No, I did not share it yet, did I?
No, not yet.
No, I was opening it, but not sharing it. So I had a request, so I will make it full screen. I had a request from University of Pisa in Italy to share with you this link for this online survey. I hope people can see it. If not, because I cannot really use the chat for everybody, or put a question myself in the Q&A for you to see. Probably you can scan the QR code or just make a copy of the this link. Talking to the people, they told me that even if in countries like mine that we don't have Vespa, still, because we have Vespa velutina, I mean, still we have Vespa orientalis, we could answer the survey. So if people are interested, please follow the survey, please answer the survey. It would be useful. It comes from Italy. Moving down, just a few announcements. You might be maybe you are already informed that Vespa, which is the Veterinarians Association in Spain, and Apimondia, we're organizing a Bee Health Symposium 2024. Is going to take place in Madrid in June. And I don't know if you see, but I don't. This is the link where you can find the information and a provisional program as well. It's going to be really very interesting, and probably will be also talks for invasive species. Apart from the invited talks, there is also a call for abstracts to be submitted, and the meeting is in person. It's not online. And then last but not least, with the initiative of the Istituto Zooprofilatico, then Apimondia FAO and the World Organization for Animal Health, we have created a joint group on biosecurity and sustainability for a modern beekeeping. And we are going to have an international event on Friday, 17th of May, 2024 at 10, starting at 10 a.m. Central European Time. This is just the first announcement publicly. We will be communicated the information, and then you will have also a link for those that they are interested to contact us. I think that that's the announcement I had to make. And before I give the word to Jeff for closing remarks, I would like to thank everybody for participating.
Fanny, I've put the link for the survey in the chat.
Great. Thank you so much. Well, thank you all. And Jeff?
Yeah, thank you, Fanny. Well, this was the brainchild of both Robert Klebo and Fanny, as they mentioned, out of a roundtable about European, to have something on invasive species, which we've done here today. And actually, we're only 1 minute over time, 1 minute over moving to me, and I'm supposed to keep my remarks short. But I wanted to say that everything I'm hearing, and I was really encouraged by the final session where we've got all these different groups, Bee the Net, Bee Guards, Better Bee, Bee Safe Honey, and even the European Pollinator Hub. All of these are efforts to gather information, maybe do science, or maybe just do education. But we have to do more of this. And also, while I was encouraged, because a lot of it is European based, we have a lot of other parts of the world, and we have people dialing in from other parts of the world that need to be informed and maybe don't have the resources that the Europeans or others have. So we have to continue to outreach to other parts of the world with this information. So that was one of my thoughts about that. And again, just really encouraged by the cooperation so far on some of these pests and diseases, trying to learn from others, learn from what's happening in Asia before it reaches Europe in the case of Tropilaelaps. My home state is the state of Georgia in the U.S., and we just got one of the Vespas into the port of Savannah. So we're going to be going through the same iterations of, how do we deal with it? And I can tell you, it's already established. The place we didn't catch it early enough. We weren't aggressive enough. And so it is established around the port of Savannah in Georgia, and it'll continue to spread. So I guess that's the bad take home message from this is that probably some of these pests are coming to an apiary near you. So be prepared. That's the bad news. The good news is that we have a lot of people working on it, and we have a lot of sharing of information. So that's the positive aspect. And so with that, I'd really like to thank all the speakers for your time and effort in putting together the talks. I'd really like to thank the audience for sticking with us. This is recorded. It will be available, and we'll try to put together a little short summary of some of the key findings. But thank you all, and thank you for taking out part of your time and putting this together. So it's been a good effort. Thank you very much.
Thank you. Bye-bye.
Thank you, everybody. Good night.
See you in Copenhagen. We invite everyone to Copenhagen. Yeah.
Thank
Okay.
you.
Thank you. Bye.
Bye.
Oh.
Bye.
Bye.
Thank you.
Thank you.
Bye-bye. Bye.